When you start up the VPN, you can choose if you want to be fast, which is no mixing, or you want to be anonymous, which is a mixed net, so we mix your packets up, and then you choose like where you want to come in. The nearest nodes, I think here is Singapore, or where you want to come out, and then you cut and paste that, you cut and paste that QR code in, and then it just works. So that's it. We have a lot of cool stuff coming. Please try it out. It's free for a month so we can defeat fucking authoritarians like Donald Trump and all these motherfuckers. Okay. So yeah, that's it. Time for Q&A.
Okay, Q&A time. So in this stage, we will be throwing this microphone. So raise up your hand if you have a question.
Oh, and equal opportunity. Fuck the deep state Democrats as well, just so you know.
You're first. Okay, catch it. Oh, sorry, I'm not very good at this.
I just want to know what's the main complaint of your current users?
It's mostly crazy cryptocurrency people doing beta testing. So we have a lot of people in countries which have some form of censorship, folks in Russia, China. We're still working on some of the censorship prevention techniques to get around certain kind of firewalls. But mostly it's just crypto people who are token holders who are just trying out and having fun. I think we have about 5,000 to 6,000 people downloaded and using it. So, but it just started, basically. But unlike a normal VPN, the more people that use it, the more anonymous you are, unlike Tor or normal VPN. So 5,000 people is a reasonable size in M&E set.
Yeah, you mentioned earlier Mysterium and Orchid, and they both are on the market since a time, and they both struggle really to get any significant amount of users. Like, what do you think? What do you think is something we can do about that to get more people to that decentralized world?
Yeah, you gotta onboard the normies like normies. So the problem with, we looked at Orchid, I like Seven, he's a cool dude. But the problem is that they said, oh, pay as you go. So I want to pay for a gigabyte or a megabyte. Normal people don't do that. And they also required like some weird token stuff to get the thing going. And most people have trouble buying tokens, right? So what we do is we just have a normal fiat interface, Stripe. If you like Bitcoin, my BTC Pay. And we take that payment in fiat or whatever, and then an API converts that over to NIM token, and then we do an automatic buy of NIM tokens on the open market. So it's all invisible, the token part, and there's tokens that reward the nodes. It's all invisible to the end user. I think the key is to make it look and act as much as possible like a normal VPN, but also offer features that normal VPNs don't have. So we have this anonymous mode, a mixed net, which no one else has. We're the world's first decentralized, actually anonymous mixed net. You know, support, Chelsea Manning works for me, Julian Assange is a big fan, and that's something that no normal VPN has.
Okay, last question.
I'm around afterwards, so you can grab me afterwards. Run, run, run. Throw the ball.
Why doesn't Tor just add noise?
Tor has looked at it. Actually, I had dinner with Roger last night. You can ask him this question. They are considering. But Tor is not a mixnet. So Tor optimized for speed, which is reasonable for them to do back when they started their code. And they weren't like, it's complex. You have to have figure out you guys have to do some form of traffic shaping. And at the time, this was a harder thing to do. Molad's also looking into adding noise. I think they have it working on iOS or one of their clients. It's actually it's a large amount of tricky machine learning. So mixed nets, particularly what we are called continuous time mixed nets, we actually do a default, what's called traffic shaping to Poisson processes. So you don't know when your packet arrives, but you always know the average time, and that makes adding noise much easier. Okay, I think that's it. I'm sorry. Next, I guess.
Let's give a big applause to Harry. Thanks for his insight.
Clarence.
Okay, next up we have Giacomo. He's a cryptography engineer working for PSE in the Ethereum Foundation. And today he'll be telling us when to use ZK-proof, FHE, and MPC. Let's welcome Giacomo.
Yeah, it's working. Okay, cool. So, hello everyone. I'm Giacomo and I work as a software engineer at PSE team. So, as many of you know, the last few years have seen a huge generational shift in cryptography. We passed from specialized to general purpose cryptography. And this has brought exciting new opportunities for everyone to make it more practical. But this comes at a cost. The cost is that we should navigate lots of jargon and mathematics. And to get the big picture also for people that is experienced in the field, it's pretty hard, like navigating the protocols, primitives, languages, tooling, etc. So today we'll try to do something very difficult to give just an overview, but we will stay really high level, general purpose, in order to understand what the building blocks of programmable cryptography can bring. And we will just focus on the programmable part instead of the cryptography, which is how things work under the hood, because we do not have much time. So, yeah. Zero knowledge proof. So at zero knowledge proofs make one party, the prover, able to prove to another party, the verifier, that a statement is true without revealing any information beyond the mere fact of the statement's validity. So you can use this, for example, to prove your age that is above some sort of threshold without saying exactly what your age is. Secure multi-party computation is a set of cryptographic protocols that let multiple parties collaborate together to compute a function providing their inputs, maintaining those inputs for all the computation private. This is useful for use cases like voting, when you have to vote on something and you want to keep your vote private, and you do not want to trust on a third party to count the votes. Then we have FHE, full homomorphic encryption, set of cryptographic tools that enables you to do encrypted computations. What encrypted computation means is that once decrypted, you get a plain text. And this plain text is the same as if it performed the computation on the decrypted data directly. This is ideal for scenarios like outsourcing computation, like running machine learning model without letting the model owner learn about your data. Each of this block is pretty powerful by its own, but they open up fascinating possibilities by combining them. In particular, on trying to solve their own drawbacks. For example, ZKP can be seen as an efficient app-specific MPC, but combining them, you can obtain verifying the MPC computation, able to prove that the multi-party computation was performed correctly under some assumption in the key. So instead of just computing, you can also prove from input to output the computation, or you can outsource the computation. So you can rely on other people doing the computation for you. They can be more than one people. And this can enable complex cryptography also in resource-constrained device, because you're not computing by yourself. Another combination, MPC FHE, one of the biggest challenges in FHE is managing the decryption keys. And there are two main approaches. The first one is with MPC distributing the key generation. So you have multiple parties, and they can jointly and manage a single FHE key, where no single party has the ownership of the key. And the multi-key FHE, everyone has a key, and they should combine the key to perform the secure computation. On the other hand, since FHE is just addition, multiplication of ciphertext, you can achieve sum of product of encrypted values, so you can build generic MPC. With ZKP and FHE is the most experimental and is basically trying to tackle two questions. The first one is, how can I trust that the encrypted value was correct under some assumptions, like is a correct BFE ciphertext? Or how can I trust that the computation was done correctly? And all three blocks combined is you can combine them, it's technically feasible. We can add ZKey to make verifiable MPC FHE combination. You can add T's, trusted execution environment, to do the ZKey and participate in the MPC FHE, but we still need to take into consideration that many real-world problems can be solved with just one vanilla block, like just ZKey or MPC. And defining resources, constraints, and unique needs of your problem can help you navigate all the space of the solutions and help you to make the right choice. I'm running out of time, so thank you.
Okay, we have 3 minutes Q&A. Raise your hand if you have a question. That's a little bit far. I'm gonna try.
That's why I outsourced to you, DAB.
Maybe I should give it to you.
Hi.
Hello.
What are the most interesting use cases for every single one of the technologies that you've seen?
Like ZK, MPC, FHE, or the combination?
I mean, is there a combination application yet?
Yeah, there are some not applications that, like, I cannot say that they are production ready. There are some explorations and research. So you have mainly like tooling that can help you to distribute the key of FHE in MPC, or you have like some sort of initial research in verifiable FHE, like proving that your ciphertext is encrypted correctly. So there's still lots going on, and as I said, it's hard to keep up with everything, so maybe I'm not aware of other stuff. But in general, yeah, I think the most exciting thing is trying to make like advancement in the FHE verifiability, because this can be really a breakthrough.
And I don't know if I can make another question, but is there any framework yet for fully homomorphic encryption with contracts, like for mainnet in Solidity?
When you speak about mainnet in Solidity, I think that FHE is mainly off-chain stuff. There are some teams that are working on on-chain FHE as well. But yeah, you can find like the state-of-the-art in the tooling and developer experience is not like as the ZK one right now. So there's still lots of work to do in libraries, tooling, and frameworks. Right now, there are good libraries, good frameworks, but mainly for experimental research more than going to production.
Thank you.
Thank you so much.
I think we have time for one more question.
Thank you for the presentation.
Yeah.
Is FHE general purpose? Can we use it for all computation, all kinds of computation?
So I'm not 100% sure, but FHE is mostly additions and multiplications, so you can maybe emulate everything with those operations. And so, yeah, you can have some sort of general purpose FHE going on, but all the nuances about like the constraints on how efficient it is or how it can be applied on small devices or other stuff, it still depends on what kind of backend you are going to use. Yeah. I think
Okay,
we have 5 seconds.
Let's give a big hand to Giacomo.
Thank you so much.
Next up, we have Rosu. Rosu is a software engineer. He works for PSE, focusing on MPC research. Today, he's going to tell us about MPC tooling and how to create MPC apps. Let's welcome Rosu.
Hi, everyone. My name is Rasul. I work in MPC research team of privacy and scaling explorations. And today I want to talk about MPC tooling, or how we can create MPC apps. So what exactly I'm going to go over is like first short introduction, what is MPC? Then I'm going to talk about applications of MPC. And then I'm going to cover tools we work on in our team that allow people to create MPC apps. And then short example, interesting example of using these tools. So what is MPC? MPC is an interactive protocol that allows parties to jointly compute a function or their inputs while keeping those inputs private. So let's imagine that we have a public function f that takes 2 parameters, x and y, and let's say party 1 provides x parameter, party 2 provides y parameter, and parties will be able to compute the output of this function while keeping their individual inputs private. So there are 2 kinds of MPCs. First one is app-specific, and second one is general-purpose MPC. So app-specific protocols, MPC protocols, are designed to represent one specific function. So let's say threshold signatures, Shamir secret sharing, and PSI, and many others. And general-purpose are designed to represent any function, including all the app-specific protocols as well. So there are many applications of MPC. I'm going to mention a few examples. So it's like privacy preserving machine learning, cost narcs, MPC Stats is another great project that PEC team works on, and etc. So first tool I want to talk about is called CircumMPC. CircumMPC is basically a project is a fork of Circom. It's a famous ZK DSL, but it compiles to a universal MPC format called Bristol Fashion Circuit that can describe Boolean and arithmetic circuit. So why we chose Circom is because many ZK/cryptography devs already know Circom, and it will be easier for them to create circuits in Circom. And there's also a big number of circuits written in Circom already. For example, CircumLibML, and they can be reused without changing the code. And that's actually what we did in PEC as well. We just took CircumLibML, Kathy's library, and we were able to run MPC circuits, ML, in MPC. Another tool I want to talk about is called Summon. Summon is a language for collaboratively summoning computations. And it's another tool that my teammate mostly works on, Andrew Morris. And Summon is TypeScript like DSL, similar to CircumMPC, with a goal for user-friendliness. It can be used from or in TypeScript, and therefore it allows to build everything end-to-end in TypeScript. So if you know Cursive team, they already use a Summon tool as well in their apps. And the last tool I want to cover is called CircumMPSpeeds. So first of all, MPSpeeds itself is a big framework that people can use to create MPC apps, but it might be a bit hard for beginners to start with it. So what we do, CircumMPSpeeds is basically a transpiler from Bristol format that generated by Summon compiler, by CircumMPC, and a transpiler from Bristol format to .MPC representation that is required to run the circuit in MPC, with MPSpeeds backend. And this project shows an example of running CircumLibML, machine learning circuits in MPSpeeds, and you can find benchmarks and everything, every information about this in the repo. And yeah, as I said, the same tool can be used to transpile circuits generated by Summon as well, not only by CircumMPC. And the last thing I want to talk about is an example of using these tools, specifically Summon. It's a matching game for friends and lovers that Barry Whitehead was talking about last year on DevConnect Istanbul. It's called 2PCs for Lovers. So basically, you can play with your friends or with your lover, and you can choose love. But if you choose love, but the result is friendship, only you will know about your feelings, even if your friend knows advanced cryptography. Yep, and you can try it here. Yeah, that's it. Thanks for coming. You can find me by my username, Curry Rasul. Yep.
Thank you, Rasul. Any questions? Oh, there's one. I probably need some help. No? Do you want to try?
Yeah, let's go. We mic here. There? Sorry. Sorry, Jordi.
That was a good direction, so.
Okay.
I have a question. Did you explore using MPC for building interoperability or bridges?
No, actually. No, I don't think so. I don't think so, no.
Do you have an idea?
Like, for example?
Opinion? Yeah, I mean, building interoperability protocols with MPC.
No, we weren't doing this. We mostly were focusing I work mostly on CircumMPC. So we were focusing on privacy preserving machine learning, like mostly. And yeah, not on that case yet.
Yeah, sure. I mean, we are just exploring it and getting into it. So wanted to see like more opinions and builders around that. Okay, thanks.
Sorry if I didn't answer.
We see a question over there. Yeah.
Oh, this is the mic? Oh, sorry, I didn't know this was the mic. Circom is usually targets an R1CS backend, and so I'm assuming all of these other tools also. And it's kind of, I guess my question is, do you pay a price for that? Are there other MPC arithmetizations that you work with, or is there something inherently related to the Searcom tool chain that you find useful here?
Sorry, your question is, do we have...
So my question is that...
Sorry. Oh, okay, sorry. I was not here when the dice was introduced. But my question is that Searcom is typically targeting an R1CS backend, and so I'm assuming all these frameworks and toolings are doing the same, but there are some pretty clever other arithmetizations, and I'm wondering if MPC is solely in this domain, or you can make use of other things like Plonk or other arithmetizations.
Yeah, I think it's like, as I mentioned, it's a fork of Searcom, and we don't target R1CS. Instead, we target Bristol format. Bristol format is a universal MPC format that can describe arithmetic and Boolean circuit. And yeah, it's just like a super simple format. And from this format, you can already, I don't know, also transpile it to whatever backend you want. So for example, MPZ library is like another library that PSE works on. You can target this library. You can target MPSpeed's library, yeah, etc. Yep.
Let's give a big applause to Rasul.
Thank you.
Thank you, Rasul. Okay, our next lightning talk will be from Enrico. Enrico works for PSE in the Ethereum Foundation. Today, he's going to tell us about multilateral trade credit set-off in MPC. Welcome.
Hi, guys. Oh, sorry. So my name is Enrico Bottazzi, and today I'm going to introduce you to multilateral trade credit set-off in MPC, which is an application of MPC. And this is a work joined with my colleagues and fellow researcher Nam and Masato, which are also part of the PSC team inside the Ethereum Foundation. So let's jump into that. First of all, I want to introduce you the concept of a payment network. So as you can see here, the payment network involves 3 firms. Each firm has a balance, and each arrow in this graph represents an obligation, like some amount of money that a firm owes to another. And the problem of this payment network is that they are kind of stuck, because each firm, given their balance, they cannot pay another firm. So for example, firm 1 cannot pay firm 2 because they are waiting firm 3 to pay themselves. And the same goes for the other 2 firms. And apparently, the only way to solve this problem is to use external liquidity, which we know that is expensive. But actually, there's another solution to solve this problem, which is multilateral trade credit set-off. And we can see how we apply that from the figure on the left to the figure on the right. And you can also intuitively understand this thinking about, like, if you owe money to your friend Alice, Alice owes money to your friend Bob, and Bob owes you money, you don't need to make 3 payments to settle everything. You can just remove the debt from the system. And another example that might help people understanding it is how the application Splitwise works. So what we achieved is a way to remove obligation from a payment network without leveraging expensive external injection of liquidity. So this is an example of multilateral trade credit set-off on a bigger scale applied on the network in Sardinia, in Italy. And the cool thing that you can see is that the more are the firms participating in it, the bigger, the higher the chance to detect these cycles of credit and debt, and therefore the greater are the liquidity savings for the firms involved into the payment network. So this is actually something that exists in the real world. Like the flag that you see on the top right is the one of Slovenia, a country in Europe. And this is how the process works. So the firms that decide to join the system will send their credit data to this third-party agency managed by the government. And this agency will reconstruct the graph, perform this set-off, so remove these cycles, and return the updated data to the firms. While it works in practice, there's a very low participation rate. And this leads us to our research thesis. We believe that the limited participation is due to the fact that these firms have basically to give up all the information, the view on their sensitive trade credit data to this government agency. And we also believe that if we could build the same system with privacy embedded into that, the participation will be higher, and this will also yield, as we said before, greater and higher liquidity savings for the firms involved in the system. So what do we mean by privacy? First of all, we want to hide the balances of the firms. We want to hide the amount of each obligation, and we also want to hide the topology of this payment network. So in practice, it means that we also do not want to reveal the fact that there's a specific obligation between two firms in this network. And how does this work? We basically replace, like before you had like the government agency there. Now this is replaced by a set of MPC servers that are able to perform this operation somehow obliviously. So unfortunately, I don't have time to go through like the details of MPC and the algorithm that we construct, but I want just to bring the most significant results of our research. So we were able to significantly reduce the asymptotic complexity of this algorithm to be performed in an MPC environment. And we did that mostly through two techniques. One is secure graph anonymization that allows these servers, these multi-party nodes, to anonymize the graph before opening its shape. And the second contribution is the secure network simplex, which is a network flow algorithm, and we built its corresponding and efficient version in MPC. So we are going to publish a paper related to what I described soon, and you can check my blog to be notified, or also follow me on Twitter to see the result published. Thanks for your attention.
Thank you, Enrico. Anyone has any questions? Raise your hand, I can see you, and I can throw this to you, hopefully. Okay, this one's close.
All right. My question is, what happens if party one has a higher interest rate than party two? Is that able to factor in interest rates?
Yeah, we didn't get into this part, basically. So we are just tackling this problem from a cryptographic perspective, not getting too much into the details of the process.
Hey, great use case. How do you do can you touch a bit the secure graph anonymization? Like, are you using something like an oblivious RAM? Like, what's the actual MPC technique to anonymize the connections?
Yes, so basically for that we borrow a technique from this field in academia that is called graph anonymization, that is not related to cryptography. And this is mostly used by, like when a company, for example, wants to open source some graph, but they also want to hide the data behind the graph. What they do is they use like this kind of obfuscation or perturbation technique to the graph. And for example, we use a technique that is very simple. It's called like random add and deletion. So you basically just randomly add some edge in the graph and randomly delete some edge in the graph. And what you get out of that is a new graph, which basically like the entropy generated by this mechanism is high enough such that you cannot infer information from that. So I guess that it's also correct to mention the trade-off, because since we are also deleting edge, we are somehow sacrificing some of the optimality in the algorithm, because basically some obligation will disappear. But I think this is a trade-off that we are willing to accept.
We have one more question left. 1 minute.
Thank you. Does it relate to blockchain in some possible applications?
No.
Not yet?
Oh, maybe one more. Oh, there's a question at the front. There's a lady here. Oh, sorry.
Thank you. Yeah, thank you for the talk. So basically, it creates an equivalent graph from the initial graph, and then what happens after that? It's being reconstructed. And it looks like the algorithms that you described is basically like AC encryption, where some rows being perturbated and then switched with each other or something like this. So there's supposed to be a key by which you can revert the procedure and then do something with it. Or
Yes, yes. So I have 7 seconds. Like the idea is that after the graph is anonymized, these parties of the MPC will have an open version of the graph that doesn't really conceive any meaningful information. And what they will do from then, they will perform this algorithm, which specifically is about like solving the minimum cost flow problem over this graph in a MPC, like linear secret sharing way. So it basically means that all the values that are part of this graph are split between parties. So every time they do, I don't know, an addition, a multiplication, or a comparison between secret share value, they will also get, as a result, another secret share value. And in order to reconstruct this value, in order to see what's behind the real data, basically all these parties need to collude and recompose the value from the shares. So that's how we guarantee the privacy, basically.
Oh, we have time for one more question.
So the results are is a chain of liquidations, right? So can this result be used to reconstruct the initial debts? So, for example, if I get 100 liquidated and my friend also gets 100 liquidated and another friend gets 100 liquidated, that means that there were some relations between us, and people could just use this to reconstruct the original debts which we want to hide.
Yes, yes, that's true. I mean, like one of the assumptions that we make in this construction is that the firm itself are not malicious. So a firm is interested in protecting their own data, and they're not trying to collude with other firms to fetch, like, I don't know, some intermediary party in this cycle. And what I would argue is that they could do this anyway, even without this system. So it's not that we are trying to solve the problem of a firm not being able to see if there's some intermediary party between themselves. So probably I didn't explain it very well, but like in our, let's say, threat model, we don't consider the firms as a potential attacker. We only consider this MPC server as a potential attacker that tries to fetch information from this graph.
Okay, thank you, Enrico, for sharing MPC tooling. Our next lightning speaker is Separis. Separis will be showcasing some of the work the PSE members have done when they were diving deep into FHE MPC during the second quarter of 2024. Let's welcome Separis.
Hello, everyone. Today it's gonna be another version of my pro crypto style of talks, which is we speed run absolutely about a lot of concepts. Try to get as much as possible, hold your seat and put your belt on, and let's go together. So the motivation and goals for this talk are mainly see which are the basic common questions that we have about FHE, what is even FHE, which I will get shortly into now, see where we can apply it, where we have been able to apply it, and see what limitations and alternatives and conclusions about those we have so far found. So FHE, why, how, and what? Basically, the easiest way to map that in your brain is we are able to compute among other people's private data. And so the results are always encrypted, meaning whatever we get out of the computational result, only us can know the answer to. The why this is useful, I mean, you can sort of see this as like an untrusted TEE somehow. So imagine if instead of TEs being in hardware, they were just an encrypted thing that we all work and run on the top of math. There's like a lot less security assumptions that then we need to have. And how we do that? Well, we are based on lots of different primitives, but I would say the most important one is lattices, for example. But this is likely for other, like, more advanced or mathematical talks. So I've tried to abstract basically everything that is related to this core math. What can we build? So one of the first really small explorations that we did was, can we actually make Photoshop, which can be software as a service, but run on an FHE server? So basically, my picture is private, and the server doesn't know anything about my picture, and I will tell the server I want to do these edits. The server will perform those without knowing anything about the image, and will return me the image encrypted later. So only I can decrypt it. So far, server doesn't learn anything, doesn't know anything at all, but I got my picture edited. And this is basically what we did with Mario here. We can go like further. So we created some kind of frog crypto shitty game, I would say. We thought, what if we could do more with our frogs? And so one of the things that we decided is, well, let's make them fight. So now you have an arena which runs on a server that is basically performing all of the FHE stuff. And so you can put your frogs there, they fight, and you just know what was the outcome of the fight. But you don't learn the strategy of the rivals, you don't learn absolutely anything at all, which can be fun, can be useless. I'm not really sure, but up for you to judge. The two most important reasons we learn is that it's a big pain to write these things. Like, the Photoshop was okay because it was a negative of an image. Then we got into the Pokemon kind of thing, and it started to be like, it's taking me time to write this. And the more you want to do, like, the much harder it becomes. So writing Boolean circuits by hand was not gonna work. The second thing was, we found a way to actually crack this thing up, which I will go through in a minute. So in terms of speed and it being terribly slow when you want to start doing like more elaborated things, there's a really nice talk by Neil Imert, which you can fetch on YouTube in the Ingonyama channel. He basically cracked a way to do really fast entities. And summarizing it a lot, entity is the core operation of FHE, which is embedded into bootstrapping. So the general idea that I want you to get from there is we can perform like 65,001,024 point entities in 1 second. So if we can adapt our problems to look on this way, well, it looks promising that we will get some significant performance in order to do more things. The second thing is, what do we want to build now? And so forwarding that, there's some ideas that we have discussed. Of course, this is not like we are committing to do that, but these are just ideas that have flourished from this exploration. We can do private social trust graphs, meaning I can basically say how much do I trust people in a completely private graph that no one can see. And we can make queries to this graph about any other person, and we will know how much we can trust them based on how much we trust our peers. No one learns absolutely anything about our relations, but we get useful information out of it. The second one could be we do private web search at civilization scale. So imagine we can do these private information retrieval protocols, and we get Google's index database, we perform an encrypted search, and we get encrypted results out of it. So we are just bringing completely private, no incognito mode stuff, web searching for anyone to be used. Questions and conclusions. It was really cool. FHE is slow, and it will be like that maybe for some time, but it's really powerful. One of the things we worry is, well, there's maybe like primitives that are more powerful than that. And if we know those exist, should we focus on FHE? Because maybe we can just focus on the next thing and like get even more benefits and more powerful primitives. Is MPC enough? Like, are we overkilling with the problems and the solutions that we over-engineered here? And how much can we optimize this? How can we move forward? Like, I would say this is like the classical type of stuff that I think we got some insights and that we have further questions on. So that was the end of the speed run. I hope you are still there. So please, if you have any questions.
Thank you. Questions, raise your hand.
Hi, thanks. Just a question. You say that it's slow. So what are the most factors that make it that slow?
So there's a lot of trade-offs that you can take here, basically. But the main idea is you're working over lattices, and therefore you're accumulating some error. And the more operations you perform on a ciphertext, the more you need to like clean the error out such that it doesn't eat up the useful information. Mainly just to give you some kind of idea, now if you want to perform a byte addition in consumer level hardware, we are at around like 4 seconds maybe or something like that. So terribly slow for a lot of things. But there's a lot of subtleties and details that you can definitely optimize for to get the problem like much, much better.
There's one question there.
Have you tried using 4080 Super for your computations? Because they have the new chips?
Yeah, so I would say, of course, hardware will be the bottleneck, but we are at the point that we need to make this a hardware problem and not a purely theoretical problem. So that's why I showed basically HAIR, which is an FHE compiler made by Google. So one of the goals is we have this bootstrapping operation, right? And we want to have as less sequential bootstrapping operations as possible, because until I don't do one, I cannot do the next one. So this is like cool research topics and cool ways in which we can try to optimize our programs such that the final representation that we get allows us to just throw this thing into a ton of like graphic cards, let's say, and get a significant speed boost. Whoa.
Any more questions there?
Have you tried optimistic bootstrapping? So where you're
So there's I mean, we've checked them all so far. Following this line, the last thing that I've seen that got my attention significantly, it's going back to circuit bootstrapping again, mainly because they have figured out a way to like see everything as a graph problem and remove all of the dependencies among the graph, so that the bootstrapping, like you can do all bootstrappings in parallel, essentially. So you can throw this to a GPU at the beginning, and you got it all solved. This is the theory. Then you need to implement it, and there's constants, and they are massive, and you run into issues. But I would say we have looked at them all. Maybe this is what personally I'm the most interested on, but there's proposals definitely on lots of different like paths that you can take on that regard. Yeah.
Okay, time's up. Thank you, Superis. Our next lightning talk will be given by Diego Kingston. Diego is a co-founder and also the head of research at Aligned. Today, he'll be giving us an introduction of the hash-based proof system. Here you go.
Thanks a lot for having me here. It's a huge pleasure to be presenting this. It will be kind of a speed run because 5 minutes to explain this so that you understand is too few, but we'll try our best to get you excited about this. So why are hash-based proof systems important, okay? So they are used right now by many projects, and they have helped develop performant CK VMs that make developing provable applications easier, because now you have to just write ordinary code and something else is going to take the gory details of generating the proof and all that. So what are the properties that hash-based proof systems offer? First, we can work over smaller fields, which reduces a lot the overhead that we have in representing the variables. Then another advantage is we don't need any kind of trusted setups. There are like minimal security assumptions depending only on hash functions. And it's easier to generate recursive proofs because we don't need to do any kind of field emulation or elliptic curve operations, which are very expensive operations to perform. Okay, so what are the main ingredients for hash-based proof systems? First, we need linear codes. In general, we are going to use Reed-Solomon codes because there are efficient algorithms for performing the codification. Then we need a collision-resistant hash function, for example, Ketchak, but you can use others such as Poseidon 2. And the idea is that we are going to commit to these code words, and then we need an arithmetization procedure, for example, an algebraic intermediate representation. So the concrete choice of the linear code, the hash function, and the arithmetization will affect the performance and efficiency, determining proof size, whether it's easier to do recursion, prover time, verifier time, okay? Some examples of these proof systems are Starks with Fry, Circled Starks, which have shown amazing performance, being able to prove over 500,000 hashes per second for Poseidon 2. Ligero, Breakdown, Bnews that works over binary fields and can be an interesting option to build new CKVMs. And FryVnews, which also works over binary fields but has smaller proof sizes. So how do we use, for example, Reed-Solomon codes to build a polynomial commitment scheme, which is the main ingredient of many of these proof systems? So the idea is that at some point, what we do is we compile the program we want to prove to a set of polynomial equations that have to be fulfilled, okay? And everything boils down to showing that this polynomial has zeros over some set, or it evaluates to some value at some point set, okay? And how we can commit to a polynomial, what we can do is we choose some values, a domain, and what we do is we evaluate that polynomial over that set D. And that is what we call the Reed-Solomon encoding. Typically, we choose a nice domain. And to show that we are not going to change those evaluations, what we do is we build a Merkle tree to commit to those evaluations. And one thing that we need to build these commitment schemes is to have a way of showing that we evaluated this polynomial correctly. And so here, the main ingredient is a theorem, which is the remainder theorem that says that if a polynomial evaluates to the given value at a point, then the polynomial minus the value divided by x minus z should be a polynomial. Okay, and the idea is that we can commit to this polynomial or this function by evaluating over the domain and committing to the Merkle tree. And we could show that this is in fact a polynomial just by giving the coefficients, but that wouldn't make proofs short. We want logarithmically short proofs. So the idea is that we can use the Fry proximity test to do that, which has logarithmic size, okay? That is something you'd like to look when you are trying to learn these proof systems. And well, here is a basic idea of Fry, but what you do basically is divide a polynomial between even and odd parts, and then you do some random folding to reduce the degree of the polynomial by half. This is the same trick you use when you perform the FFT. And here are the two phases of Fry. You have a commitment where you commit to the code words, and then you let the verifier choose some positions where he wants to query and test whether you are cheating or not, okay? And the interesting thing is you get logarithmically sized proofs, and the prover runs really, really fast. Okay, and here there are like some cool things you can do to have even faster things by leveraging Mersenne primes, but you have to move to a different construction, which is Circled Starks. Okay, it's more or less the same as this, but with some tricks. Well, and thank you for listening to me. Happy to answer any questions.
Thank you, Diego. Raise your hand if you have a question. And just to remind you, this is not just a throwable, it's a microphone as well. So please speak to it. We can hear you. Any hand raised? Ah, there's one. You can probably help me. Thanks.
Oh, there's a microphone.
The microphone is there? All right, fair enough. The question is when you actually do these hash-based proving systems and you do aggregation, because really it's efficient. You want to keep your proofs really short, but they're at the same time, and you aggregate them up, right? Or even if you have different prover systems with different commitment schemes, you still want to aggregate them up to generate one proof, right? Because you don't want to schlep around 10,000 or 100,000 proofs. What's the most efficient way of these aggregation schemes like lattice folds that you've encountered?
Well, recently they released some papers showing that you can use folding schemes with Starks. That could save you the work of having to do recursive proof generation, okay, when you want to link all these pieces. Of course, with performant CKVMs, it should be easier to perform recursion because you just use the code written in Rust, you execute it on top of the VM, and that way you handle at least the first conversion to a Stark proof. And then you can use Stark recursion, maybe using this idea of folding. And so I think that this will greatly accelerate the development of CKVMs and the kind of things we can prove using hash-based proof systems.
We see another question here.
Hi, thanks. Nikolai from Terminal 3. Actually, my question was very much related, but I'll still ask. So these folding systems and hash-based proof systems, very much interested in that. Do you know what's the concrete performance of that now?
Right now, no, because there is no implementation. This has been released a few weeks ago, but I am sure that either us or some teams will start implementing because it can offer some advantages in terms of performance. Of course, then we also have to see whether these ideas can also be easily extended to binary fields. And that is also something really promising because you can reduce a lot of the overhead when you have to represent variables, okay? The problem with CK is that typically you have to represent your native variables in code, like a U32 or Boolean variables with finite field elements, and these in general are very, very large compared to the variable you want to represent, so that adds some overhead in memory and performance.
We have time for a short question. Okay, thank you so much.
Thanks.
Let's welcome our next speaker, Leo. Leo is a member of the PSC. He's been working on a new language and ZK-proof compilers. So today he will be talking about a modern ZK-proof compiler. Let's welcome him.
Hi everyone. So we are going to talk about a project that we were working on and at PSC. That I mean, when we apply for this, speaking about this, we were working on this, but now we have stopped working on this. So we are going to go through what we were doing and the reasons why we stopped working on this. So a little bit of the retrospective of a project, let's say. I started working in 2022 on the CKVM that at that moment PSC was working on. That was based on Halo 2 kind of a plonkish arithmetization, and because it was very complicated to build something like that on top of Halo 2, it's inevitable that you need to abstract things. So as an engineer, I found there like a treasure trove of really interesting abstractions to be able to build the CKVM on top of Halo 2. A lot of layers on top of the Halo 2 to be able to reason about it and to kind of like, abstract on it and build what we require. And there's like things like the state machines. No, it seems like was like the right level of abstraction to think about proving computation on top of a plonkish arithmetization, and the cell manager that was used to kind of place things in a more efficient way on the plonkish table, and also how to combine like composability with something that was called the supercircuit and subcircuit. And all this was built when I started working here, but I started kind of learning about it. And I found like this idea that these abstractions actually, if they are made in an accessible way, could make much more easy for the average developer to develop CK apps, and that something like this could help multiply CK apps development. And with that, we started Chiquito first as a DSL in Rust. Then we added a Python frontend to make it even simpler, with the idea that developers didn't need to learn Rust, they could do it on Python. And then after bringing it to several hacker houses and working with builders at an experimental level, with more information about how it should be built, we started kind of creating our own front-end, our own parser for a language that kind of has a similar syntax to CIRCOM, but has state machines and more things. So in the end, what we implemented, the state machines, that are as the kind of the definition, like the constraints of the transitions of state machines are kind of the circuit, and the witness is the trace of an instance of the execution of these state machines. And that's kind of like the main abstraction at Chiquito. And then with the cell managers, we abstract how that is converted to the Plonkish table and how the witness is arranged in an efficient way and is independent, so can be configured in different ways to try different things. Then another thing that we built is like arbitrary Boolean expressions compilation to polynomial identities. No? So the constraints are expressed as polynomial identities, and we built a system that any Boolean expression, as complicated as necessary, it will be automatically compiled to this. And we kind of develop a mini theory about how to build this that can be used in other languages, like how to compile any Boolean expression into polynomial identities. Then we also, like compilers has to optimize, and through optimization can get to better performance than, wow, I'm going super slow. So yes, we did more things, and this is how it looks, the code. And yeah, you can, like for example, here you can see like arbitrary Boolean expressions that are compiled automatically to constraints. And we saw like it was super easy, and users really quickly could develop like complicated things like Blake2 hash that in the CKVM we couldn't implement on top of Halo2 normally with it. And we checked that it has the same performance as manually doing with Halo2. And we found some things that can be better. And then the reasons to sunset it is basically CKVMs, the race of CKVMs make us reason that now we are in a kind of CKVM era, that the applications we want to build now are probably better built on CKVMs. And thank you for all the people participating in different stages on Chiquito, PSC engineers, researchers, and grantees. And yeah, thank you very much.
Thanks, Leo. Question time.
I had to accelerate a lot.
Any questions? Oh, there. I'll go closer.
Oh, I wanted to throw it.
You want to throw? You can do it next.
It's okay. Hey, Lance.
Yo, what's up, Leo? So question on custom constraint systems. I saw that there was one of the libraries that you all use. When it comes to CCS and ZKVMs, are there any ZKVMs that are implementing for that to go from like plonk to air?
But that wouldn't be like to go plonk to air. That would be kind of a easy translation, I think. Like not a VM, but from plonk into air would be kind of easy translation, no? Because the difference kind of how the rotations work in the arithmetization. So we actually, yeah, we implemented the backend as powder, that is kind of air. So
powder?
Yeah, powder, yeah.
Yeah, okay.
One of the, yes, I cannot show this. Like,
yeah, I'm familiar.
Yeah, so we implemented a backend for powder that is kind of air, yeah, so yeah, it's easy, Plonkish and even CCS, we implemented the backend in CCS, Sonove, so yeah, it compiled to, we didn't have time to check the performance on Sonove, but it was something that was compilable to many different proving systems.
Dope. Really cool.
I think there's a question here. Yeah. Okay. You want to start?
Who?
This one. Oh.
Hi, thank you, Nikolai from Terminal 3. A few questions, actually. First, can I verify your proof on chain, like in BN254? That's basically the only on-chain verifier now.
Yeah.
And then you said you'd made Python, but can I do a Rust code and compile it? And because most of cryptography is in Rust, so Rust is very useful here. And
let's do these two, and then if you want.
Okay.
So you don't forget. So the first question on chain, yes. So we for the CKVM we implemented a verifier in Solidity for the Halo2 proof. So as long it depends on the proving system that you use in the backend, if it can be verified on because it's kind of independent on the proving system, can compile to different proving systems, and they generate different proofs. So it depends on that. And the second question, Rust, is built on Rust. Chiquito was built on Rust, and then we put like a parser, a frontend. But yes, you could interact and connect it with other Halo2 circuits built on Rust and kind of actually integrate it together. And another question? Or, no?
Okay, we have one more question. Okay, there.
Yeah, better you throw it. No?
You want to throw it again?
Okay.
Last opportunity.
Oh.
Too short.
So bad.
So I actually not sure I understand the difference between a ZK VM and a ZK compiler. Like a ZK VM takes your Rust code, translates it into like, let's say RISC-V instructions and proves that. But
okay. Yes. So a CKVM is one circuit that its witness is the trace of the execution of an instruction set. So the CKVM is not a compiler, it's a circuit that takes as witness the trace of the execution and proves that you have executed correctly the program. So in that case, you compile Rust to this instruction architecture, and then you execute it and you get the trace, and that's verified. A compiler takes some kind of description of what your circuit does and actually kind of outputs a circuit itself. So you could build a CKVM on a DSL in a language. I don't hear you, yeah.
so what actually executes the code? Like what does the proof proves if it doesn't prove correct execution, right, with the compiler?
Yeah, with the compiler, you generate a circuit that proves something about a witness. So a CKVM is a type of circuit, no? It's a type of circuit that proves the execution of the trace of a specific instruction set. Okay, but a circuit can prove any witness like follow certain properties, certain constraints. In the case of the CKVM, the constraints are the correct execution of the instruction set. Happy I knew that question. I knew the answer. If they ask something different.
I don't think we have time for one more question, but please feel free to talk to Leo after his talk. Thank you so much.
Thank you. Bye-bye.
Next up, we have Pierre. Pierre is from PSE as well. He's a cryptography engineer, and he will give us an introduction on post-quantum, this is a bit tricky, post-quantum signature scheme for Ethereum. Let's welcome Pierre.
Hi. All right, so a bit of context about why do we need post-quantum signature schemes for Ethereum. So what can quantum computers do? So you can think about it as quantum computers at being very good at exploring large search spaces, which are typically the kind of spaces in which cryptography operates in. So there was a researcher called Peter Shor that proposed one day an algorithm that would solve the discrete log problem very efficiently. So the discrete log problem is one of the most fundamental problems in cryptography, and he showed a very efficient algorithm that would break this kind of problem very efficiently. Hashing, however, is safe. So quantum computers can make some improvements at it, but we basically consider them to be safe. So it's really about the ECDLP and things that use the ECDLP and also pairings that will break catastrophically. So what does it mean for Ethereum? And my goal here is just to give you a bit of an intuition of what Ethereum is faced with. So here is a bit what it will look like for Ethereum in terms of constraints. So the consensus layer in Ethereum uses some aggregation scheme, which is BLS signatures. And what we would like to do for Ethereum is basically to keep some aggregation scheme because it makes running a node easy. You don't have too much hardware requirements. So we would like to, that does not require too much hardware from the node runners, and that will still be post-quantum ready. Same for the execution layer. So we would like to have a post-quantum scheme that lets us keep the account-based model that we have on Ethereum, and yet minimize the requirements that will be made to wallet teams when we ask them, when Ethereum will ask them to maybe change the signature scheme that they use. So that's the constraint space that we have. We want to avoid to have signature schemes that impose too much of a load on the nodes, and also we want some signature schemes that make it possible to have a post-quantum secure execution layer where we can make transactions safely. So what kind of cryptographic objects do we have to do that? What is the toolbox that is at our disposal to do that? So here what we want is a cryptography that can run on our everyday computers, but can still remain secure against adversaries that have access to quantum computers, basically. And so to do that, we already have some answers. So we have hash functions, as we saw before, which are safe, we can say. We also have lattices. So here, lattices are nice because they are pretty fast when you want to generate signatures, but they generate pretty large ones. And we also have things like isogenies, which help us get small signatures, but are kind of slow. They are getting faster. And they don't have an aggregation scheme yet. But this is some of the cryptography tools that we can use to help make Ethereum post-quantum safe. And so I give some examples here. So there is the module-based lattice signature scheme, which is a recent NIST standard, I think. So here you see it use lattices. You also have the Winternit signatures, which are hash-based, and you can also use some stack-based aggregation technique with a post-quantum resistant signature scheme. And you can see in all of those proposals, it's based on lattices, hashes, isogenies, and you will see those things come again and again and again in the proposals that will be made for helping Ethereum be post-quantum secure. So what's next? So it's pretty hard to predict when a quantum computer is going to come up, and also at what rate it's going to come up. Maybe it's going to come up one day, it's going to pop up, and we are going to be like, oh wow, okay, now we need to switch, or maybe it's going to come up slowly but surely. Some think that quantum computers are not even physically realizable. Recently, there was a blog post by Scott Aronson where he was saying that basically, he would be very surprised if quantum computers don't come in the next 10 years. And this is a probability density with pretty fat tail, so I think it's not very useful, it's not very telling something. And there was a proposal by Justin Drake that he was thinking about using quantum canaries. So the idea of making a puzzle that can only be broken by a quantum computer, so that if you break it, you get a lot of money. But at least we will know that when the puzzle is broken, it will be the time to switch to some post-quantum schemes. Thank you.
Thank you, Pierre. Question time. Do you want to throw it?
Yeah, okay. So I cannot do it with my foot, right? I cannot. No?
I don't know. I guess you can.
Oh, wow.
It's
okay.
soft enough.
Oh, no, I can't. Okay. No. Right.
Thank you. Pretty good throw. With NIST approving just post-quantum algorithms now for the first time, do you think that the NSA or the governments in general know more already about the state of quantum computers available?
I have absolutely no idea.
Like there's no public evidence of anything, right? That the Chinese or the US or anyone would have.
I would definitely lie on the paranoid side, but I have absolutely no idea. Yeah.
Okay, next question.
What makes lattices so well suited to post-quantum security? I hear them coming up a lot.
So, it's just that you can think of it as if you try to find the key that you use in your scheme, if you use lattices, quantum computers are not at all efficient with this. So the goal of cryptography in general is to find very, very hard problems and to turn those problems into schemes, basically. And the problems that you have with lattices are very hard and for which quantum computers are not very good at. So I think it's hard to go into the mathematical details, first because I'm not very familiar with them, but also like in 10 seconds, it's hard to explain in 10 seconds, but basically you can think of it as a very hard problem, which is still complex for quantum computers to solve. Yes.
And what challenge is Ethereum currently facing in adopting the post-quantum signature, or what issues may arise in this progress?
Oh, that's a good question. So you have changes on the consensus layer. So for the clients that are trying to reach in the proof of stake model that we have, you have changes in terms also in the execution layer. So for all the transaction approving logic. So I think there will be engineering challenges. For instance, does that mean that we need to audit everything again? Do we need to make standards again? Yeah. And also I think it depends of the timeline, because if one quantum computer pops up tomorrow, then the challenge to do it will be much more pressing than if we have like a much larger timeline to think about. So it will also be an engineering and human problem. Yes, yeah.
Okay, that's everything. Thank you, Pierre. Our next speaker is Henry. He is the head of ecosystem from Starknet Foundation. Today, Henry is going to break down Stark Proof into simple blocks and give you some high-level ideas of how they work. Welcome, Henry.
Hello. Hi, everyone. Welcome. My name is Henri Lieutot. I work at the Starknet Foundation, where I'm the head of ecosystem, and I'm going to try to explain Stark Proof like you're a 5-year-old. There's many ways to explain proof. This is mine. It's not perfect, but I hope you learn something. So how I'm going to go about it is the following way. I'm going to first explain quickly what is proving, what we're trying to achieve. I'm going to talk about something that is called arithmetization. I'm going to talk about execution traces and how they get used into proofs. I'm going to talk about error correction code, and then I'm going to try to put everything together so that you have a clearer picture. So first, let's talk about proving. What is proving? Proving is a person trying to execute a computer code and that person is called a prover, and he's trying to convince the verifier that the execution happened correctly, without the verifier having to re-execute the computation. Now, the kicker where this gets interesting is that there's an asymmetry between prover and verifier, and it's very efficient for the verifier to verify rather than re-execute. So we save a lot on compute on the verifier side. So that's what we're trying to do. So first, now, how do we do that? We first use one step that is called arithmetization. So arithmetization, from a high-level perspective, is the act of turning a computation into set of polynomials that represent said computation. I'm not going to go too deep into that, but assume the following. When you use a computer, you know that your computer program can be turned into logic that gets executed on transistors and on zeros and ones. You can get the same result by having your computation represented as polynomials. And when you design a computer program that you want to prove, you have an expected polynomial, which is the polynomial where every execution of your program will have points falling on it. Okay? So let's talk about an execution trace. What is an execution trace? The execution trace is the equivalent of the step-by-step log of you executing a program. If you were using a CPU, for example, it would be the register of the list of all actions, all registers, all counter, all memory steps at every single step of the execution of your program. So executing your program is the sequence of all those specific steps. Now, what do we do with this execution trace when we're trying to prove is we're turning that execution trace also into a polynomial. So you take all those data points and you turn them into points and you interpolate a polynomial that will go through this execution trace. So now you have two polynomials, right? You have the expected polynomial, the one that defines the program you're trying to prove, and you have the executed polynomial, which represents the execution you just ran. So what do we do with that? We apply something on top of it that is called error correction code. Error correction code is something that is used in telecommunication to transmit data and verify its integrity. It gives you two properties. One, you can detect error very easily, and two, you can recover from those errors. But we're not trying to recover from errors, we're trying to detect those. So we're using those techniques on those two polynomials to check if the execution polynomial is as close as possible or the closest way possible to the expected polynomial. That's how error correction code is used in Stark proof. So now, wrapping it up, what we're trying to do is to convince the verifier that the execution happened over the same polynomial, that the polynomial he was expecting, which was defining the computer problem he was trying to solve. And with error correction code, we're just taking any tiny mistake that might have happened somewhere and we're amplifying it. So instead of having to check every point in the execution, the verifier can just take a few points and then check using error correction code whether there was an error somewhere. I hope that makes sense and you learned something. And here's the actual explain like I'm 5 explanation of Stark proofs. Stark proofs are 5 years old worst nightmare. When you're going to the swimming pool and somebody tells you, hey, if you pee, it's going to turn red and everybody will see it. Stark proofs are the exact same thing for computation. If you try to cheat at a single place, it's going to blow up everywhere and everybody will see it and will know you're a cheater, and you're not going to be able to convince the verifier that you did your computation correctly. Voila, thank you.
Thank you, Harry. We should probably invent something that makes your pee turns red in the pool, right? Any question? There's one. I'll do this one.
How do error-correcting codes and polynomial commitment schemes differ?
I'm not entirely sure I can answer this question. I don't know enough about it, so I'm sorry.
Okay. Oh, I see another hand here. This lady.
By the way, thank you so much for the ELI5. Want to really understand a bit more when you say you take a few points out at the ECC stage, you take a few points and amplify it. Is that to understand that as a statistical probability that it might have an error that you cannot detect because the sampling wasn't done, to capture those points? Or is that just we should feel comfortable believing that as long as it passes, it is error-free?
I'm not sure I understand your question, but I think what you're saying is there,
sampling?
Depending on how much samples you're taking, you have a different level of certainty. Yes, that's actually the case. When you're taking samples, you're going to see error with a probability, and the more sample you take, the lower the probability of you catching, of not catching an error is. All right.
Any other questions for Henry? Oh, there's one here.
Hey, so do I understand properly that this verifier need to have this execution polynomial like a sample that it needs to check whether it's following the same steps?
Yes, it does get a form of it does get some sample from the execution trace. Originally in proof, there are like protocols so that the verifier asks the prover, hey, can I get this point? Can I get this point? And then he verifies a few, but using some fancy cryptographic technique, you can actually get away with just giving, the prover can get away with giving a bunch of random points and having the verifier just use them off the bat.
We take one more question. There's one there.
If the prover can select the points to send to the verifier, can he select the points in such ways that the verifier won't be able to detect the error?
So the fancy cryptographic technique I mentioned makes it so that he can't select points that are comfortable for him. So, so then, like, he can't really cheat. Hopefully. All right, thank you, everyone. I hope this was useful. Cheers.
Thanks, Henry. Lots of insight from ZK proof. Well, sorry, Stark proof. Okay, our next speaker will be Alexandro. He is a developer at PSE, and he's going to tell us why private voting is important. And let's welcome Alexandro.
Hey everyone. Yeah, let me just see if this works. Cool, it works. Yeah, so I work at PSE. We do a lot of programmable cryptography, cool stuff. Come talk to us. We have a booth there. But yeah, this is Macy in 5 minutes and why private voting is important. Just an agenda. We'll talk through what is Macy, why do we need it, how it works, and just look into the future. So Macy stands for Minimal Anti-Collusion Infrastructure, and in a nutshell, it's a protocol that allows to run private on-chain voting. These are some of the properties that we try to push. So collusion resistance is increased because there's only one entity which can be certain of the validity of the vote. If that is trusted, then things get a little bit better than other voting protocols. You cannot really prove how you voted because all the votes are encrypted. You can also, you can edit a vote by nullifying it, but whatever is sent on chain must be processed. And even if we talk about this trusted entity, the coordinator, even if they are malicious, they cannot really produce any false output of the vote. So why do we need this? I mean, I think voting is a very sensible topic. Bribery and collusions happens everywhere, and I think something that a lot of people find very close to, and it's great to work on this for that reason. But yeah, like, let's take an example like patriotic funding or voting, where more people coming together can actually make a difference, but if it's easy to collude, then the results can be gamed. And also think like, if you know how people vote, then you can also be conditioned. Like, there's some people just don't want to spend some time going through the candidates or whatever you're voting for, and you see like a famous person, oh cool, I voted for this, why don't I just do it? But if you don't really know, they cannot prove to you that that's their valid vote, then you could just maybe think for yourself. And then bribery is reduced because it's hard to prove and it's hard to collude. And our goal is to make voting more democratic and fair. So in a nutshell, the architecture, the smart contracts that work on any EVM chain. There's some circumcircuits that are used to prove that all the votes sent are valid or invalid. And the tally circuit, which tallies all the vote. So these are run by this trusted entity, the coordinator, and all the results are posted on chain for everyone to verify. yeah, there's some SDKs and TypeScript stuff if people want to integrate it. Hopefully you do. And yeah, how does it work? As a user flow, you come and register into the platform. You register with your Macy key, which is not to be confused with your Ethereum key. You can just prove you're human, prove you own a Zupa's ticket, and then you register into the system. Then you can send encrypted votes that only the coordinator is able to decrypt. And you also sign them with this Macy private key, so no one else can send votes on your behalf. And then as a user, after the coordinator processes everything, you want to verify that everything was done correctly. The votes are encrypted using a CDH, so there's a share key between you and the coordinator. It is signed, and in the vote you specify who you're voting for, whether it's like a yes or no vote, or like you're giving some sort of weight in quadratic voting. And yeah, that's encrypted, sent on chain, fully encrypted, and you also send a public key that you used to generate the share key, so the coordinator can just reverse the process. To finalize, the coordinator just takes all of the votes and just all the events from these smart contracts, and then just generates the ZK proofs using the circuits that we talked about. And they'll just post them on chain. They cannot censor any vote. They cannot prove something that is not happened. So that's some of the cool stuff about it. And yeah, looking into the future, what we try to do is to make it easier for people to use and actually get someone to use it. Some of the research topics that we have in plan is to actually decentralize this coordinator figure using MPC and try and make it even more harder to collude. There might be some time to also look into new voting mechanisms or like funding mechanisms that could be integrated. And maybe we'll also be thinking how to just rethink the architecture and kind of integrate it with a lot of other PSC protocol like Semaphore, RNR, and Exubia. Okay, so we are running a Devcon QV round. There's like 250K put by the impact teams at Devcon, so you can go and vote. You can try Macy. You just need to prove you're an attendee by using Zupas. This is what it looks like. Just try it out. Just be gentle, because yeah, just be gentle with this app. Don't break it, please. But yeah, that's just showcase how Macy work. And yeah, that's it. 5 minutes.
Thank you, Alessandro. Questions? Do you want to try this one for me? Thanks.
Sorry, dude.
You mentioned at one point that there was a proof of humanity required for the voting. How do we achieve that without relying on a centralized entity? And also, how do you protect against Sybil attacks in your voting chain?
Yeah, that's a good question. So to prevent Sybil attacks, we have this concept of gatekeepers. So you need to prove, that's fully customizable. So whoever runs the vote will say, hey, I'm only accepting someone that proves it's a Devcon, so by scanning the ticket, or like owns something like an NFT and other things. So that's how you protect against Sybils. So Macy is only as good as the Sybil solution that you decide to use. And for the trusted assumption is that this coordinator figure could be removed with the MPC. So you have like a collaborative snark. I mean, I'm not really going into this stuff. So at a high level, just like instead of having one coordinator, you'd have multiple, and there might be some sort of consensus, some sort of way of how to say, to make it hard for them to also not post the results and not collude between themselves. But yeah, that's probably where we're going. And there's some smart people in PSC that already thought how Macy would look with MPC. So hopefully we'll be able to implement that very soon.
I think we have a question at the back there.
In the beginning, the receipt freeness of the vote, and that it's impossible to show who you voted for. But what if the user would simply share their private keys and then reveal everything that they did? They would still be able to prove the vote in that situation.
Yeah, that's a good point. So the thing is, like, when you cast a vote, you can nullify it. So, I show you, hey, I voted for this, but then you couldn't trust me that I actually did, unless the coordinator colludes with this other entity. And yeah, one of the other issues is if you give out your key, then they will be able to like post votes on your behalf. So like it's up to the user to not sell the key. Yeah, that would kind of mess up with the system as well. And hopefully we'll be able to find some good solution for that. Yeah.
I think there's a system called something with bear vote, like the animal, that has a property like you need an additional salt to prove that it was actually you. And if you provide a wrong salt in the proving process, the result comes off of somebody else's vote.
Okay, I'm not familiar with this, to be honest, but yeah, if you just hit me up later and just describe this, that'd be interesting to talk about.
Any other questions?
Yeah, I have some question. There is any possibility you have a credential for get quality voting about your knowledge? For example, you know computer science, and there is a proposal for some upgrade in the system. There is any possibility to do this?
So like to automate like some sort of execution after the tally is produced?
Yeah, the proposal is made,
okay.
You get a vote, and the calculation about your knowledge is the quadratic voting.
And then there's some sort of action that happens after? Like that's what you mean, like in, let's say, DAO governance or something?
Yeah.
Yeah, okay. That's not something we explore yet, DAO governance. Actually, talk to a lot of people about it today. So, yeah, that's still possible because the tally is posted on chain, so they can be automated. There's a hook after the tally is fully proved. On chain, there's the data, something can happen. That's totally doable, yeah.
Yeah, thank you.
Okay, thank you, Alessandro. Let's give him a big applause. Let's keep the energy going. And the next lightning talk will be from Andy. Andy is the product manager and also project coordinator from PSE. And his talk's topic is the blind man's elephant. Let's find out what's going on.
Hey, hello. So I know many people here work multiplying matrices and like doing a lot of polynomials day in, day out. But I think my talk is going to be a little higher level on like how programmable cryptography can solve one of the, I would say, most important use cases for our space and in general like society, which is like private identities. And this product vision, it will be more like a high-level overview about what characteristics do we want and some sort of approaches that we have been seeing in the space. Yeah, trying to solve these issues. So as we are in Thailand, I thought it was great to start with an analogy of this blind man elephant illustration because this is the land of the white elephants. I think people who are inside the identity space, we kind of like see a lot of acronyms thrown everywhere, like DAD, POD, SSI, and those are these ideas like self-sovereign identities, verifiable credentials, decentralized identities. Those are all useful and have nuances, but at the end it has some core properties which I want to like explore in this talk. I'll say these are the properties that we care. And probably we can grow the list even more, and we can even make security assumptions models to understand how, like in which sense these properties we want to achieve. We want flexibility, we want verifiability, we want privacy, we want decentralization, self-ownership, transfership, etc., etc., etc. But I would say if I were to sum it up to like the core properties that we really want to achieve with this are basically 3 actions that I think we should pursue and target with programmable cryptography in this identity space. First, and the ones bolded, are things that a user will typically do in order to leverage private identities. One is the capacity to import all my identities and data into something, a container. Let's call it a wallet for now. The other one is to generate proofs or generate an artifact that then I can take and then prove an identity and attribute something about myself so that I can execute an action. So my proofs being useful elsewhere. So if we were to summarize like all the complexity that we have in these three kind of like steps and actions, it turns out that it's a bit easier to reason about like what type of like cryptography systems and targets do we want to achieve with programmable cryptography in identity. So the first section is let's import all. Let's import all my identities, my data. And what does that mean? It means that for all the documents and data that exist in the world, in the digital space, anything that is signed, we should and want to target it to bring it to private identities cryptography use cases. And that means obvious things like your national ID card, your passport. There are great teams in here targeting that, but also driver licenses, signed documents, PDFs, credit card transactions. Maybe we can like leverage from WhatsApp, Telegram, Uber reputation, social graphs, Spotify history. There's all this signed data that I think we need to hijack and literally start adding into all of these containers that it can be called, it can have very different names. And we need to do that permissionlessly. That means without asking the national government to allow us to do that. We need to do that privately without them realizing that, because maybe you want to use it for things that the government doesn't approve or the Spotify or whoever. And we want to make that data verifiable. That's why CK, MPC, FHE, and other programmable cryptography technologies are so good. And we need to achieve like a Web 2 user experience in order for this to be useful and get adoption. And that means technically that we have a lot of challenges, that we need to support a lot of hashing mechanisms, a lot of signature schemes, a lot of data structures, standards. That means that we need to invent new things, like not only wrap things into CK, but also like 2PC and MPC, proxies, and have like wallet-like experiences if we really want to achieve this property. The other one is proof facts about them. And if we want to have a great user experience, then we need to generate proofs in useful ways, doing selective disclosure in things like less than 1 second, in targets where our users are going to be. And that means browser in your laptop, but also browser in your phone, and also means native phone, like apps. And that means mobile side proving or client side proving is extremely important, which not every programmable cryptography project is targeting. And it needs to be very cheap or even free. It needs to be very easy for me as a non-technical user to leverage my data and import it and generate facts about it whenever a website or a platform queries and I respond to that. The other one, yeah, technically this means WASM, mobile proving, small RAM memory, like low bandwidth environments. That means leveraging techniques like proof aggregation, recursion, folding, different verification layers, exploring things like co-snarks in order to do delegate proving, exploring things like proof composition, like I don't know, client-side proving with one proving system like Spartan, then aggregating on a CKVM, and then like proving on-chain with Groth16. Those are kind of like the solutions that we're seeing because we want to have cheap, fast, composable proofs of our data. And lastly, we want to basically do very useful actions with that. And the most obvious candidates are voting, forums, chats, etc. But there are things that are popping up like, yeah, data syndicates, so data marketplaces, where a lot of people can just add up their data and then make charge, basically, to do statistic analysis on that private anonymized data. We can do reimbursements, compliance stuff, a lot of UX on Web3, like multi-sigs, account recovery, social recovery, are needed, like need identity. So I think that's where our solutions in this space are going to be extremely important. Humanitarian cases, anti-civil, etc. So yeah, basically we need to be able to do useful actions. And one of the biggest, I'll say, challenges is like nullifiers. The nullifiers is like a strong problem. I just listed different approaches and levels of like nullifiers where the government, basically no nullifier, that's the worst case. And best case is like, yeah, not even the government trying to collude will be able to, see that you sign up for a really controversial service. So yeah, first, last things, this needs to be secure. Post-quantum is like a must-have now, because like in 5 years, you're doing voting and it gets like capture the data and then decrypted later. It could be a problem for you. It needs to be interoperable, no vendor lock-in. It needs to be movable from wallet to wallet. It needs to support key rotations, live checks, et cetera, et cetera. So these are some properties that we want to achieve, and I think we all in this space are trying to actively work on. So to finalize, I think the 3 key messages that I want you to take is like, first, let's hijack everything. Let's take all the data of identity sources and data sources and try to bring to our use case, on-chain or off-chain. let's try to discover novel use cases, like different interactions that we can unlock with this new data provenance things. And now let's build new Lego blocks to build a better future. Thanks.
Thank you, Andy. There's a question there. Ah, I did pretty well.
Thank you.
Good throw.
Yeah. So question, great to see the product perspective for once, and I really like the three stage components, and product deals with human nature, right? So human nature usually runs on incentives. So if I give an example for the government gives you the right to drive a car. Yes. So you have to get a driver license, therefore you have to get an identity.
Yes.
So it usually goes backwards, right, from 3 to 1. So I was wondering, what are the cases that you've seen that the incentive is so big that you would then go and find an identity source? Because if you want to use this as an actual identity that people use, they usually don't start with, wow, this is so private and it has like encrypted proof and hashes and everything.
Yeah.
So I was wondering, what do you see that that has kind of grassroots in reality when can really bring the masses back to the platform, to platforms like this?
Okay, I think that's a great question. What I understood is like, what are places where we will search for identities or data where people are already there? I would say like, yeah, I will start with where are people there? Like, it's very hard for us to request to everyone to sign up to a system, but it will be way better if we just say like, yeah, all people are interested in driving a car in these locations. Let's just use that as a like source of starting point to bring their identity on-chain and to do actions on-chain and to do like voting and et cetera, et cetera. So yeah, like, I don't know, like anything that you sign up that has a digital signature, I think it will be great to just hijack it. And the more people use it, the more common they are, the more used to they are, like Face ID, Touch ID, all these secure enclaves, I think they're great to start to do that.
Just to follow on that, like the way I approach it, just to say it in a couple of words, we have a company called Grappa, and we use reputation, basically. So we're saying you want to prove your reputation. You want to say that you did something in life. You want to have some kind of attestation from somebody else that you are noteworthy in something. That's usually a start for an identity. That's usually, I want to prove this to the world. I start with that. That starts to be kind of the seed of my identity, and then I cannot forgo that.
Yeah.
Right.
Yeah. No, great use case.
So one question there.
Okay.
I saw on your slide verifiable oblivious pseudo-random functions.
Yes.
What's the where do you see it fitting in?
Yes, that's a technique that a couple of teams in the identity space are exploring. And I think it's great that they didn't get to all the technical details, but it's basically a network like MPC of nodes. And basically how it does is like it calculates the salt with this like in an MPC fashion that is deterministic. But no node by themselves can calculate that salt for you. So I think this solves two really important problems. One is like using your private data and this salt generation process, which is deterministic, you can recover your account or you can recover your identity even if you lose your phone or like your cache data. The other one is that, yeah, just like way better user experience. And the other one was that no government can calculate that unless, yeah, they tap into the, like, these process type, like private data. So, and we can make these like very custom. So like, yeah, you can choose like private data that only you know in your head, plus like private data that, I don't know, it's verified in a credential. So yeah, in short, very strong for nullifiers and yeah, anti-discovery mechanisms.
Any more questions for Andy? Okay, thank you so much.
Thank you.
Our next lightning talk will be given by two speakers. So the first one, Kevin, he is from PSE, he's a software engineer. And the second speaker is John. I believe he's a computer science alumni from Columbia University. And today they're going to talk about a framework called MPC Stats. So it allows users to query statistical computations without leaking any privacy. Let's welcome them.
Yeah. Hello, everyone. So we're MPC Stats team at PSE. So today we'll introduce our project, and it's currently worked on by Jern and I and Kazumune. Yeah. So the goal of our project is to build a framework that allows users to query statistical computation across different data providers, while guarantee the data privacy and also the correctness of the result. We've implemented common statistical operations using MPSpeed, which is a well-known MPC framework. We've supported 12 statistical operations and also some common table join and array concatenation and filtering. So users can define computation like this. And we also integrated TLS notary so that the inputs to MPC are authenticated from some well-known websites so that we can prevent garbage in, garbage out situation.
All right, thank you, Kelvin. So basically, right now, we are talking about MPC, right? So intuitive approach for MPC is that having all parties, data providers, data consumers, to join as a computation parties, right? The bad things, the good thing first, let's say, is that it's free verifiability because everyone is in the same computation set, right? So they know what computation is done, right? I request mean, I know that this guy just compute mean for me, right? The bad thing is that the data providers, consumers, everyone need to be online at the same time. And it's really hard, right, for many numbers of data providers, especially when the number of data providers grows, the computations grow skyrockets so badly. So how to solve that, right? We use another approach called client interface, which basically means that the data providers and data consumers are not in the computation parties. So there's three phases. The first phase is that data providers secret share their data through some delivery links. They can log in, share data, and log out. And then another set of computation parties compute data, and once it's ready, data consumer just log in to get it out. So this is good because they are now the data provider and consumer doesn't need to be online at the same time, which makes sense. And it also doesn't grow with the number of data provider because the cost of the MPC computation is actually from the number of the parties in the computation parties. The bad thing is that the data providers and consumer now need to trust the parties, right? It depends on our setup. If it's malicious, we need to trust at least one of the party is right. And again, because we are not joining in the MPC computation party itself, we have no idea what is the function that they calculate is actually the one we want. But again, the trust assumption is the same, that if we trust that at least one for the malicious setting, right, of the computation party is honest, we can be sure that they just run the computation that we want, like mean or median or anything we want. So use case, we are thinking about cross-departments data sharing, government, verifiable salary data, any survey research for policy planning, and yeah, many more, let us know. So demo time. So this is currently up and running. We're still under maintenance, final optimization because it's pretty big, so we will notify soon, but it's pretty interesting to explore ETH balance inequality at Devcon. So what it means, that you guys can use your Binance to share it privately. We won't know your Binance balance, but then we will be able to calculate the interesting stat we will show later. But you guys should join this group first. So we will notify by today or tomorrow once the Docker file is smaller so that it can make sense to run in this internet in Devcon. So the caveat, right, because we want to be upfront, so we will only allow you to share privately the free ETH in your spot balance of Binance. And again, the parties could still learn the number of digits, although this comes from the limitation of the TLS notary itself, that the parties still know the number of digits of your Binance balance, but again, we won't know actually the number. And again, this is the trust assumption that we trust that our three party doesn't collude, right? And yeah, please join this Telegram group. We will get updates soon, and anyone who joins will get a chance to win an NFT and win a lottery as actual cash. So yeah, so this is just a quick go through. It will already be in our README, in our demo. So get Binance API key, just go, Binance API key, everyone know how to do that. Get the API key and secret key. Make sure it's read-only. And then, yes, so notarize this. This is only our script that you need to run. You just git clone and you run. And make sure that your Docker is opening and running on your laptop. And then, yeah, you just run this. again, this is just one line, and each address is just address for receiving the price. This is not the address for the Binance. This is just to send the price if you want one. And yeah, this is the website. So we are having max ETH balance of Devcon, mean, median number, and Gini coefficient to make sure of the inequality. So yeah, join us. Thank you so much.
Thank you, Kevin, John. Any questions? Oh, that's too far. Okay, you got it.
Hey, great talk. It's not clear to me, are you guys trying to collect like aggregate statistics from like multiple parties? And if that's the case, and that's the use case, did you explore something like a PRIO-like system, using like function secret sharing? I don't think MP Speed support that, so I'm kind of curious. It should be much, much more efficient.
Yeah, thank you so much for the suggestion. Yeah, I think we've looked through some of it, but this limitation mostly is through the number of data providers. So right now, again, like FHE, multi-key, functional encryption, secret sharing. Yeah, we looked through some of them, and we're thinking of using some, but again, the limitation right now is that the state-of-the-art MPC for a huge number of data providers is still matters, and we think, again, because we make sure, right, that we don't want the competition to just grow indefinitely with the number of data providers, so we still choose this, but thank you so much for
Yeah, so just look at function secret sharing. I think it would really boost your results.
Thank you, I appreciate function secret sharing. Note.
Do we have any other questions? Oh, there's one.
Hi, I was trying to scan the TG QR code that you showed just now, and it says link expired for me. Is it just t.me/MPC stats? That's the link?
Yes.
Okay.
Sorry about this.
So t.me/MPC stats.
Yeah.
Any other question? Can I ask a question? I know that the federated learning is similar to preserving privacy, and then the medical hospitals, they're having a lot of confidential data of the patients, so they use federated learning. I just wonder what you're presenting, how different it is from federated learning.
Yeah, so basically federated learning is like you trains offline, right? Like data is still there, and then you send the update on the gradient descent or anything to your machine learning up in the air, right? So basically you train everything update, but now MPC, it means that you gather data from different parties and compute at the same time. So for federated learning, so it can use, actually it depends on what types of thing you use, but it can also use MPC itself. So, but yeah, when it comes to federated learning, people still consider like not too many parties all at once. But when we're thinking about stats, we're thinking about like population. So we wish to make it more scalable in terms of like number of data providers itself. But yes, I think a lot of federated learning techniques still use MPC, but we just want to make sure that MPC framework that really scalable to a huge number of data providers. Yes.
Okay, thank you. Okay, thank you very much, Kevin and John. Our next talk is from Vivian. Vivian is a computer scientist from PSE. She'll be talking about privacy preserving group. Let's welcome her.
Hello, everyone. My name is Vivian Plasencia, and I'm a software engineer in the Privacy and Scaling Aspirations team at the Ethereum Foundation. And today, I will be talking about privacy-preserving groups. Privacy-preserving groups are groups where the identity or the actions of the members is private. There are a lot of use cases for this type of groups, and one of them is everything related to anonymous interactions, like anonymous feedback, anonymous voting. There is also an interesting use case related to prove that you own a credential. So there are a lot of credentials that take time to prove and verify. So something that you can do is to ask people to verify the credential once and then add them to a group. And then they can just, every time they want to prove the credential, they just have to prove that they are a member of that group. And that's a cool use case of this type of groups because you can keep privacy. we cannot talk about groups without talking about anti-civil mechanisms. So there are a lot of ways to use anti-civil mechanisms for your groups. And an anti-civil mechanism is a method to prevent fake or duplicate identities in your group. And something interesting that you can do to have a stronger anti-civil mechanism is to combine many anti-civil mechanisms using logical operators, so that you have like a stronger anti-civil for your group. There are a lot of examples of anti-civil mechanisms. So I will mention a few. One of them can be like invite codes. You can send people an invite code and they can join a group. And another can be like social media information, like GitHub followers or personal stars, and also a number of commits on a specific repository, also Twitter followers, or if you follow a specific user. Those can be anti-civil mechanisms from Web 2. And there are also anti-civil mechanisms that we can get from blockchain information, like your account balance, the number of transactions. And the identity protocols are also a nice way to have anti-civil mechanisms for your groups. Example of this is Anon@har and also Open Passport. There are a lot of other protocols that are really cool anti-civil mechanisms, like Ethereum Attestation Service, SDK Email, TLS Notary, and POP. So some projects can be useful for privacy-preserving groups and also for anti-civil mechanisms. One of these is Semaphore. This is for groups, anonymous interaction, but it's really useful for if you are part of a group, then you can be added to another group just if you are part of another different group. So also Supas, which is a project that we are using here, it has groups and also can be used as an anti-civil mechanism. And Bandada, which is an infrastructure to manage privacy-preserving groups, and it also has a lot of credentials. And CKKit, which is a set of libraries and algorithms, so that also has groups and can be used for anti-civil too. So the three main ideas from this presentation that I would like you to remember are like privacy-preserving groups can be used to verify credentials, to have a better user experience in your applications. Also that you can combine different anti-civil mechanisms to have a stronger one. That's very important. Maybe it's not your case, but for your application, but it can be the case for some other applications. And some projects can also be used as anti-civil mechanism. They were not created for that, but they are really useful as an anti-civil mechanism. So that's the third point. So thank you very much. And yeah, I will be around. Feel free to ask me any questions about these topics. Thank you.
Thank you, Vivian. We have some time for questions.
Hi, Vivian. I've used Bandada before. I just find it difficult to understand. Like this works with IDs, right? You get a group ID and user's IDs. So how do I use these group IDs, or what happens after I get one of these groups set up?
Yes, Bandada is compatible with Semaphore, so you can use the Semaphore identity package to have the Semaphore identities, and you can add the commitment to a Bandada group, and then you can work with that group. And it's also, since it's compatible with Semaphore, you can do anonymous things with the members in your group.
Any other questions? Is over there? I see some people wearing the meerkat hat, but
Hi.
unfortunately we're doing the ball of throwing. Yeah, please.
So, quick question. So, are there any practical way to forcefully remove someone from a group? So, I understand that it's kind of easy to verify someone and try to add to a group, right? But I mean, as the group have run, and there might be a reason to remove someone forcefully. Are there any practical way to do that?
Yeah. There is. If you want to do it with code, there are functions for that. If you want to use it, in case of application, for example, Bandada, you can use do it directly in the dashboard. Yeah, there is a way, an easy way if you are using code or not. Yeah.
Can you explain the mechanic behind, like how can you like maintain privacy of everyone and also kind of can specifically remove someone?
Yeah, in the group you will have identity commitments, which is like it's like a public key, like your account that is public, and you have a private value. So the commitment can be public, and commitments are not attached to the identity of the real person. So you can, I mean, the person, it's a commitment, so people don't know like who is that commitment.
Okay, thank you.
Do we have other questions for Vivian? There's one question here.
A lot of these privacy groups are opt-in privacy groups. Is there any opt-out privacy groups as well that you guys have looked into?
That you mean like if you can be, if you want to be
Like-
out of the group, you can do it?
But yeah, like by default, everybody.
Yeah,
at
there is an admin, and the admin can remove people. So yeah.
Okay. Thank you, Vivian.
Thank you.
Our next talk is also going to be about Semaphore V4. So let's welcome our next speaker, Sidor. He's going to show us some new features of Semaphore V4 and some of the importance of the ZK technology. Let's welcome him.
Hi. So hi folks, I will start introducing myself and then I'll present some news regarding Semaphore and our future plans. So I'm Cedar. I work as a software engineer with the PSE team, and in the past years I have mainly focused on improving the developer experience of some PSE projects. I'm talking about what Semaphore is, Semaphore V4, so some news, and then our roadmap. So first of all, Semaphore, as far as I know, is one of the simplest client-side zero-knowledge protocols. So the core circuits only contains 22 lines of code without documentation and like empty lines. Generating a proof only takes less than 1 second on browsers, and verifying a proof on chain only consumes less than 300,000 units of gas, which means like around 5 cents on Arbitrum. But what is it? So Semaphore is a zero-knowledge protocol that allows users to prove their membership in a group and send messages such as votes or feedback without revealing their identity. In addition, it also provides a nullifier mechanism to prevent users from reusing existing proofs. So Semaphore is basically a general purpose protocol, so you can use it for any use case where you need a layer of privacy. We have been working on Semaphore for a few years now, and we have mainly focused on developer experience until V3. But with the latest version, V4, we also focused on interoperability and efficiency and on-chain costs. In particular, we have made 2 important changes. We have a new identity schema, which uses EDDSA key pair, and we have optimized the data structure for groups. So let's go a little bit deeper. We replaced the old identity schema with an EDDSA key pair. EDDSA is one of the most efficient public key cryptography algorithms used in zero-knowledge circuits, and it makes the new version of Semaphore much more compatible with other existing protocols which use EDDSA. In the old schema, the public commitment, which is like the public identifier of the Semaphore identity, was a Poseidon hash of a secret. In the new schema, the public commitment is the Poseidon hash of the EDDSA public key. And in addition, it also allows users to sign messages and verify signatures inside and outside ZK proofs or secrets, which has been and will be hopefully pretty useful for some applications, like Zupass, which uses Semaphore V4. So then we optimized the old data structure, the incremental Merkle tree, and we created a new data structure, which is based on the old one, the lean incremental Merkle tree. So just small improvements that made it much more efficient, especially when the tree doesn't have many leaves, so for small groups. The key improvements are two. 0 hashes are no longer required, and the tree grows dynamically now. So 0 hashes. I just want to show like the difference between these two trees. In the old implementation, if the parent node has one child, it will be calculated as the hash of that child node and the 0 hash. In the new implementation on the right, the parent node can actually equal the child node itself. So no need to calculate any hash in those cases. The second important change is about the dynamic depth. In the old implementation, the tree has a static depth. Each insertion needs to update a number of nodes which equals the static depth of the tree. And in the new implementation, the tree depth grows with the number of leaves, which means each insertion would only require updating a number of nodes proportional to the current number of leaves. So this is quite complex, so please, if you want to know more about this data structure, go to the paper we published a few months ago in the ZK-Kit repository below. Finally, what we would like to do in the next months, we would like to have a new explorer, which people can use to see on-chain groups, and which admins can use to create and manage groups. We would like to work on a new version of RLN, which is pretty similar to Semaphore. They share the same code, but RLN works with an additional layer to prevent spam. We would like to add additional tutorials to the documentation and possibly have like specifications for Semaphore V4, something that people ask us a lot of times. We will also explore and consider new improving systems, of course, and try to keep ourselves updated on the latest technologies to improve the key requirements of the protocol. So some links you can use to connect and ask us any questions. Yeah, thank you very much.
Thank you, Sidor. Any questions? Oh, there's one there. Do you want to give it a go? It's on your side.
Hello, Test. Thank you for your speech. It was good. I'm just curious to know more about Semaphore's business model. The tech sounds amazing, but I'm curious, is there a way to generate a profit from this?
No. I mean, we are funded by the Ethereum Foundation, and we are not thinking about any way to make profit.
Okay, thank you.
I think we're also not allowed to speak about profits, just from what I heard.
Okay, thank you.
Okay. Hi, I was wondering, to upgrade or migrate from previous version, does that mean like pre-existing projects need to generate new identities?
Yes, yeah. You need to generate a new identity, and one way is to derive the secret of the new identity of like the Semaphore V4 from the identity of Semaphore V3. So using the same secret and deriving the private key from the previous secret.
I have a question for how the protocol works. Do all the nodes need to be online at the same time?
Where are you? Sorry.
Oh, sorry. Hi. Do all the nodes who want to take part in this protocol need to be online at the same time, or is it possible to establish a group without all the participants seeing the other participant at any point in time?
Can you repeat your question? Sorry.
It's about the liveness of the participants.
Yeah.
So can we establish a semaphore-based communication, for example, even if some of the nodes are only online for a certain short period of time, or do they all have to be online at the same time to calculate these secrets?
Yes, they have to be online, yes, on-chain at the same time.
Okay. Thank you.
Any other questions? We have one at the front row here.
Hi. What are the advantages of using the lean IMT now data structure for like the the depth of the tree?
I think one advantage is that with the old static, with the old incremental Merkle tree with static depth, we had a range of supported tree depths from 16 to 32. And even if the group is small, like with 10 members, you had to use a Merkle tree with a static depth, which was like 16. So bigger.
So it's storage then?
Yes, for storage, and like the generation of the proof as well needs more time because the circuits has more constraints.
Okay, I see. Thank you.
Yeah.
Okay, we still have some time for questions if you have any. No? Okay, thank you, Sidor. Thanks for sharing with us Semaphore V4. And coming up next will be our last lightning talk of the first part. We have 3 parts, remember, I talked about it at the beginning. So the last of the first part we will have 2 speakers. We will have Yawen and Movin from PSE, and they will be talking about MoPro. And they will tell you how to use MoPro to develop your ZK proof on mobile and make mobile development easier. Let's welcome them.
Hi, Sawadika. I'm Yawen, or Vivian, and he's Movin. And we are going to talk about MoPro to make mobile client-side proving easy. So we found that there are more and more mobile users than compared to desktop users because of the accessibility and portability of mobile. And then there are many powerful features in native mobile. For example, the performance is better than browser, and it can access to hardware devices like camera, GPS, biometrics, and also the offline functionality and push notifications are also interesting features in native mobile. And last but not least, the mobile development lacks infrastructure for ZK applications. So our goal of MoPro is to improve the mobile developer experience. So we provide FFI, CLI, and provide templates and documentations. And we want to improve the native mobile performance to generate like ZK proof and cryptography proofs. And also we want to build a mobile development ecosystem as complete as the web app ecosystem. So we want to build packages for mobile developers and also build good communities for those who want to build mobile apps. Yeah, so our roadmap is to integrate as more as adapters as possible. For example, ZK and Hello2 and folding system, MPC FHE in the future. And we will generate the bindings for different platforms, not only iOS, Android, but also for website and gamings and also your desktops. Yeah, so we can look detail in this structure. We are now in the middleware of the MoPro is in the middleware, but we need to coordinate the backend, the proving system, GPU acceleration, and the front end is the like SDK for different protocols. Yeah, so how to use MoPro? We provide a CLI for developers to easily use MoPro init, MoPro build, MoPro create to create a iOS or Android templates, and then you can easily getting started with the app. So the benchmark on mobile, it can be speed up to like 6 times faster than Snark.js on the Mac. But the disadvantage of mobile is that the memory is really few. So we need to solve this problem. And this is the benchmark of CPU. And we will introduce the GPU research results.
Okay. So we've been researching on GPU acceleration on client-side proving for a while. And what we found is that client-side proving is a completely different story from server-side GPU. So we want to highlight two things. The first is scalability. So if you look at the right-hand side table, you can see that although there are like 9x, 10x on compute power or memory capacity of server-side GPU, it seems not that much, but the point is it can be clustered hundreds of thousands of GPU to do extremely fast computations. So on the other hand, the mobile GPU is just the one sits on your phone, so it's relatively limited. And the second thing we want to say is that the ecosystem support of the shading language, which is where we do programming on GPU, is really different. So CUDA is one of the most mature GPU shading ecosystem right now. So if you want to do development on CUDA, it's much more easier than Metal, which is the one we do GPU acceleration on your iPhone. Yeah. So we target MSM to accelerate because it encompasses 70% of the proving time in like growth 16. So the first thing is that we found that current CPU implementation is much more faster than GPU1 in the Z-Prize 2023 winners. And the second thing is that although the GPU is much more slower in this case, but when the instance size grows, the GPU has the potential to shine in larger instance size. Yeah. So few takeaways is that we still have so many things to under exploration. So better elliptical library or making much more memory efficient for mobile. And we also want to leverage all of the computing resource on mobile device and make sure the GPU and CPU synchronize in a way that maximize the computation speed. Yeah, so GPU is a totally different story, and we want to explore more.
Yeah, so here's the link to the MoPro resources, and it includes a Google form that we want to collect feedback from ZK projects, so what you need for MoPro. And there's also a GitHub link and Telegram link. Yeah, feel free to scan this QR code. Yeah, so Kopenka.
Kopenka.
Thank you, Morgan and Yawen. Any questions? Oh, there's one over there. You guys want to give it a go?
Really? I don't think I can. Oh. Thank you.
Hello. Okay. So I saw your benchmarks. So are the benchmarks comparing the SnarkJS on a browser or against Rapid Snarks on like mobile device? Like what's your performance versus Rapid Snarks on mobile and Gnark on mobile?
Yeah, so the SnarkJS on Mac is with CLI. So I use like NPX Snark full proof to generate the proof. And then the Mac is M1 Pro Max. And my iPhone is the native app. So it is iPhone 12. Yeah.
Is the native app using SnarkJS or Rapid Snark?
No. With MoPro. So it's the native bindings.
Okay.
Yeah, like yeah. So we use Rust and then generate the bindings, binaries for iOS. And then we calculate the proof with the binaries.
So do you need any specific DSL that you have to write your proofs or like circoms or like you're going to integrate other DSLs as well?
So actually we use the circom results, the Z-key and Watson, and then you can use these two things in MoPro, and then it will generate the native bindings for you to generate the proofs, and then you can use it in the native app. And then for example, the iOS, and then it will create also an FFI for Swift. So I can call like generate circum proof in Swift to generate this proof. Thank you.
Any other questions? Oh, there's one over there.
Oh, sounds nice. I just wonder about any like attempt or challenge for building like AVX specified instructions, because when it comes to like, looking at the vector databases in editor fields, they're trying to facilitate each calculation by implementing those some transformer calculation to embed it into the CPU with using AVX instructions. Are there any like attempt to doing similar approaches when it comes to doing electric curve acceleration for ZK stuff or kind of things?
Okay, so can you say it again?
Okay, so I just know about there's some attempt to accelerate some dot product calculation or like matrix calculation to using when it comes to using a transformer architecture for accelerating each calculation using AVX instructions, which is to accelerate on the CPU compiler, which is compatible with x86 architecture. So some vector databases try to use those like AVX instructions to make sure to optimize those instructions. So when I just try to looking at those approaches, I think it could be applied to accelerate on the calculation for electric curve, because we can just unloop those duplicate calculations into compiler level. That's my kind of imagination, but have you ever tried those temporal kind of things? That's my question.
Yeah, it sounds interesting, but we haven't tried that, like implementation that, and we are, welcome. Maybe you can create an issue in our GitHub, or we can contact each other, and then know much more details about your suggestions. Yeah, thank you.
Oh, we have two questions. Oh, maybe the front row first.
Hi. Here. Is your research concerning also storage on mobile, or it has nothing to do with that?
Yeah. Also the storage and memory also really filled in mobile.
Okay.
Yeah.
So and yes, with this, are you using like a different key generation for every time I want to prove something or a change is made? Because I think that this adds more to this phone storage, right? I heard from the folks of Nord that they have like a different backend that only needs one key to generate and store.
Yeah, so now when we explore the second prover, and then there's a really large Z key if your Z key is really big. So yeah, it sometimes takes like several gigabytes to store in the storage, and it's pretty big. But yeah, like the Noir example, it has really smaller Z key, and it's better for client-side proving. So maybe in the future we can integrate more proving systems that is better for client-side proving. Yeah, thank you for your suggestion.
And also on the GPU side, we're trying to use a much more efficient way to encode the elliptic curve points and scalars to make sure it is much more, efficient for the storage on the mobile device.
Thank you.
Okay. Nice to meet you. I want to ask a question about the device memory limit. Some more detail about your benchmark. As we know, the more larger your circuit or app was, then the more device memory it may take on the GPU or your mobile memory. So, for example, you have shown that you can do KCAC or SHA-HASI on your circuit to generate the proof. But I want to know for your device benchmark, 8 GB memory, how large you can do in SHA or KCAC?
So for
Yes, for
SHA.
example, you use Snap.js and your Rust binding to prove on your mobile. Use Matter, and the app do SHA hash about 1 KB or 1 million byte data as the prime image. But
Actually, for like SHA or Ketchup, it doesn't take like that much memory to generate proof in mobile. So I would say like maybe less than 1 gigabyte, but I forget the exact number.
Okay.
Yeah.
Okay, I got it. Just want to know the limit.
But yeah, like RSA is much more than like Ketchup or SHA.
Okay.
Hash.
Oh, there's one more question there. See, everybody's interested in mobile application.
When you say mobile is not clusterable, like it has to be standalone, I'm just curious. Have you like looked into, like there was like Boeing or like there's like, I mean, I guess a few software or like a few frameworks that can actually facilitate cluster computing or even like building a, I guess what they call like a cluster, distributed cluster just with mobile devices. Have you considered like looking into those and so that to just like get around the so like memory limit or like storage limit of a single device? Thanks.
Yeah, I think there would be a way we want to explore, but we want to start from much more simple stuff, which is doing the proving on your own device, and then we do the method you propose, like leveraging many others like consumer device to do so. Yeah. But it still cannot be compared to the server-side GPU when like the one in data center is like hundreds of them inside. It's really a really big difference. So when you look at the benchmark of GPU acceleration, you need to be mindful about like which device they use to benchmark. It's really different.
Okay, thank you everyone. Let's give a big warm applause for Yawen and Movin. And that wraps up the end of the first part of our lightning talks. And we will come back at 3:30 sharp, and we'll have another group of 6 different speakers lasting for 1 hour for the second part. So hopefully see you soon. Hi, welcome back everyone. Hopefully you had a nice break, had some snacks and freshened up because we have another hour of exciting lightning talks today. We'll have 6 speakers in the next 1 hour and they will be covering 3 tracks: the developer experience, layer 2, and also real-world Ethereum. So let's get started. Anyone who's at the door, please come forward, and we'll keep the previous throw ball game. Whenever you have a question, please raise your hand. I will throw the ball to you. And remember, it's also a microphone, so please speak towards the black circle on top of the square. Okay. We have next our lightning talk speaker, Gian. Gian is a tech geek from Starknet Foundation, and she's going to share her own experience about how to build a vibrant developer community. Let's welcome her.
Hi everyone, thank you so much for coming. My name is Gyan and I'm based in Bangalore, India. I'm a developer advocate with the Starknet Foundation, and I've also co-founded one of the most popular developer communities, if I can, called the Phoenix Guild. We are heavily populated in India and also have branches across the globe. Today I have a short agenda of what are some of the things that you need to keep in mind, or what could be a potential successful process to build a developer community, be it regional, be it global, or just for a particular domain, right? So I'm going to talk about first 2 things I want to highlight because they're extremely, extremely important. And if you have cracked that, then the next 3 things are pretty much a lot of empathy, collaboration, and just your willingness to kind of make this community better, right? So how do you start? Where do you start when you're thinking about building communities or building developer-focused communities, right? The first thing is, and the most important, as you can see, important stuff that comes in your email, right? Find your persona, right? Who is your main developer persona? We have different types of developers at different learning stages. We may have freshers who are just out of college, right? They are complete beginners. They have no development or domain experience. In that case, you're offering them knowledge in bridging that gap of getting into development and then being able to get them into the domain that you're building your community for. Your audience could also be people with basic development experience, but may not have domain experience. So for example, Web3 is one of the domains where if you're interested in building a developer community, then you want your audience to already have some basic programming experience, right? It would help them become much better Web3 developers if they already know how, if and loops and all of those things work. Or maybe you want to build something which is much at a higher level. So they have some domain understanding, but want to build stuff. So maybe your community is just for builders, right? People who want to build interesting projects, interesting businesses. Or maybe you have a niche domain, which is just for experts or based on diversity, etc. Once you identify this persona, half of your work is done. But make sure to be very, very straightforward in terms of who are the people that your community is catering to. If you want to cater to everyone, it will be a huge problem, right? And it will be a very hard path to build anything viable. The second is that the persona that you have chosen, write down a journey that will work for that persona. How will these people learn from your community? And make sure that the journey includes closing the loop, right? I say this to everyone who is planning to build communities or trying to work on building communities, that you need to figure out what will be the end goal for that developer who comes into the community. Will they get jobs from your community? Will they get support to become entrepreneurs? Will they get funding? What will be their goal, right? This is the second thing that you have to crack, and you have to really sit and crack this, right? Are you offering education? Are you offering entrepreneurship support? Are you offering networking? What is going to be a journey of that developer who enters your community and they exit? By exit, I mean they have found something valuable from your community, and then they are the ones who are going to give back to your community. So for example, I just put up an example of maybe a community that is catering to builders on Ethereum. So their ideal journey would be getting educated about Ethereum, which is what you could potentially offer, or build their portfolio by working on projects within your community. Maybe a research-focused community, right? Or a builder-focused community where you have opportunities for people to build businesses. Or you're a community that is focused on fundraising, supporting entrepreneurs, right? So if a mixture of 1 and 2 is what you have to crack first. Everything else that comes after is just a bunch of slides with not much wordings, right? So you need to collaborate, right? You may not be able to offer everything. So collaborate with other communities who may offer parts of that cycle for your community members. So their success will also be attributed to your community's success, right? And how will you sustain long term? A lot of communities are springing up every day saying that our mission is this, our vision is this. But have you thought long term? How are you going to pay the people who are working in your community? How are you going to incentivize the volunteers? What is it going to be for them? Is it going to be a sort of incentive that I'm satisfied after volunteering for this community? So you need to really think about what that long-term sustainability for your community will look like. And last but not the least, community is all about people. So be empathetic and make sure that you're starting small, on a small scale, talking to builders, talking to people who are your ideal community persona, and build from there. So you can focus on quality over quantity, which should be your final aim in terms of community building. And yeah, that's me, Gyan. And if you have any questions around community building, Web3 community building, or just developer community building, feel free to reach out to me over my email. That's both my Telegram and Twitter, @GyanLakshmi. And yeah, I'm super excited that you're all here to listen. If you have any questions, happy to take that.
Thank you, Gyan. Any question for Gyan? Okay. Always hit the wrong person.
Okay. Yes, just one question. Okay, building the community, what metrics are you using typically to understand like what's happening? Okay, oh, I didn't know. Okay, what metrics are you using to understand like how it's going, what's processes like what like maybe like what issues and like to
Sorry,
compare.
could you please speak to the black circle?
Okay.
I got the question.
But I believe you got me, yeah?
Yeah.
Okay.
Yeah. So I think at the beginning, I would say that don't focus too much on hard metrics, like especially metrics like how many people are coming to your meetups or how many people are joining your online sessions. These are all rubbish metrics, honestly, a lot of times. What matters is that how many people are achieving the end goal that you set out to achieve. So if you are a community that wants people to build applications on Ethereum, your hard metric should be how many teams are actually building sustainable long-term applications on Ethereum, right? And that's the metric that actually matters. To understand how to get to this metrics, of course, you do a lot of feedback loop in terms of like, hey, you attended this particular online session, how did you like it? So maybe you track a little bit of, when do people drop off your online sessions, or, when people come to your meetups, when they come to the next meetup, do you see the same people coming again? So are they getting value out of your meetups? Or every meetup, do you see different people coming in? If yes, then maybe there is a problem, right? So I would say that don't focus a lot on like temporary metrics, but focus on what your final end goal is. Like if you want builders building businesses, then that's your final metric. So you have 5 teams maybe that successfully came to a hackathon from your community, representing your community, and they are talking about your community. That's a good metric for you to have, right? So I would say that, and I'm happy to also chat about, more after. Of course.
Okay, sorry, we don't have time for one more question, but please talk to Gyan afterwards.
Yeah,
Thank you,
I'm here if you have
Gyan.
any questions. Yeah, thanks everyone. Yeah, have a good DevCon.
Next up, we have Bianca. And Bianca is the lead DevRel at Chronicle Labs. She's going to tell us how to build a developer's empire. Let's welcome her.
GM Devcon.
This session is about building a developer empire. My name is Bianca Buzia. I'm lead DevRel at Chronicle Protocol and also the founder of DevRel Uni. One of the perks of the startup life is about building a tight-knit team along the way. I remember when I first started, my very first startup, our office was someone's apartment. And to be honest, I think we spent more time playing Mario Kart than actually building the product. But then, one day, it happened. We found product market fit, unfortunately. Now, if you think that finding product market fit it's difficult, that's because it is. A lot of the teams struggle finding that. But then after you find product market fit, the next big challenge is about building a great developer experience. Every developer interaction with your product is a gift. So you need to make that worth it. Make their journey seamless and enjoyable. You already built so far, so don't become complacent now. There are around 26,000 developers in our ecosystem. What that means is that it's not enough to have a great product. You also need a great developer experience. How many of you have run npm install on a freshly cloned repo only to discover that it doesn't work? Raise your hands. Okay, me too. We've been there, done that. That's the developer equivalent of, I'm gonna deal with this tomorrow. We've all experienced that frustration. We're going from one error to the other. Nothing seems to work. And yet, we try to move forward. Sometimes it doesn't work, and that's when developers need the most our support. Developer relations is about supporting developers every step of their journey. I like to think of it just like compound investment. Every resolved bug, every clear piece of documentation, every positive outcome, those are all wins. But then, just like compound investment, losing feels worse than winning feels good. And losses have lasting effects. And they make it harder for developers to re-engage with your product. Now, there is a common misconception that motivation is all about money, perks, and praise. And while those are true, the true driver, I believe, is the constant feeling of progress. Developer experience should align with community use cases. Ideally, you want to anticipate the needs and the challenges of your developers. You need to be deeply invested. I would even add borderline obsessed with understanding and supporting your developer community. And here are some examples. When I joined Chronicle, we discovered that some of the developers struggled changing the addresses of the self-kisser. The self-kisser is a smart contract that basically allows you to authorize yourself, to whitelist yourself, to read from the oracles on testnet networks. But as you can see in the image, it has different addresses for different testnet networks. So what we did, we introduced this table in all the guides where the self-kisser was mentioned, making it extremely hard for developers to miss the fact that they need to change the address. While this small change might seem like very trivial to you, yet it had a very big impact. Developers were able to progress right away. Another example is about hackathon workshops. The challenge with hackathon workshops is that they cover many protocols and they are very tight in terms of time. All the workshops need to run back to back. However, when developers first interact with your protocol, they're gonna have answers and questions to ask. So the solutions that we came from was to have pre-hackathon workshops. Those were virtual, more time relaxed. Developers can come and build along, and they could get any questions answered. This not only that enhanced engagement, but also drove better hackathon results. So far, I share with you the positive examples, but the truth is we don't always get it right, and that's okay. A big part of DevRel is listening to feedback, even the tough stuff. For example, we heard from developers that they needed more time before updates, and they wanted to be notified. So we acknowledge that, and we introduce processes to make sure that developers have enough time, and we notify them on time. Not only that this removed the friction, but only it strengthened the relationship with the community. Developers felt heard. Now, DevRel is more than just code and documentation. It's about making developers feel seen, heard, and empowered. By using small, consistent wins and by cultivating trust and support, we're building relationships that keep developers coming back. DevRel, in my opinion, is creating lasting relationships that go beyond technology, making developers feel that they're part of something bigger. And this is exactly what motivates them to come back. Thank you.
Thank you very much. Any questions for Bianca? Community building, very interesting. Okay, thank you, Bianca. Let's welcome our... Oh, is there a question somewhere? Did I miss? No. Okay, sorry. Thank you. Okay, because some unforeseen situations, our next speaker is not here, so we will have a break. And we'll come back at what? 3:50. 3:50? Okay, we'll come back at 3:50. And we're looking for the speaker from BASE. If you're here, please come to us. Welcome back, everyone. We finally have Will from Base here, and he will be sharing his experience building Base community with us, and in general, how to build a more scalable Ethereum community. Let's welcome Will.
Hey, everybody. Can everybody hear me okay? Pretty good? All right. Thank you so much for coming here and being here today. So, hello, friends. My name is Will Benz. I also go by W Benz. They're smashing my name together. I lead communities at Base. I'm also a full-stack developer. At Base, we're a 1.5-year-old layer 2 on top of Ethereum. Our objective is to build a global, open economy that spreads equality, opportunity, and freedom around the world. We just processed our 1 billionth transaction this past week. It's still day one. Across Discord, Farcaster, GitHub, and X, there's millions of people that are part of our communities. I said, hello, friends, but we don't know each other. We're different genders, different skin colors, we come from different countries. There's all kinds of things that make us different here, that fracture us, that drive us apart, that lead to a lot of the conflict that we see in this world right now. But we're here. We're here together. All of us here left something behind that really wasn't working so well in some way. To look towards something better for us, for our friends, for our families, for our loved ones. And that, I think, is something that all of us can build a friendship on. And I think that's, in the context of this lightning talk, high level, our future is the most important part, focusing on that in building a scalable community. An open economy that anybody can be part of. Being able to work from wherever you want. Being able to live where you want. Equality, all those things I talked about. All those things that make us different. All those things that don't matter. Transparency, verifiability on chain, not having to take each other's word for things. Freedom, and hopefully, in what we see these days in the future, more peace in the world. But how do we do that? We have to make space for everyone. Builders, creators, lurkers, people that are just curious, speculators, gamers, even scammers and spammers. There should be direct paths for all of these people. And in order to do that, we have to create opportunities for everyone. I just said scammers and spammers. And I think one of the most important parts of creating opportunity for scammers and spammers is being empathetic. There's people that are born just by the lottery of life in some part of the world where they can't even leave their town. They wish that they could get on a plane to come somewhere like this, to sit next to us today. But they can't do that. The opportunities in front of them led them to that path. It's up to us as community builders to build something better, to help people discover new apps, new opportunities, new jobs, learn, educate them. For some people, it's just to make friends, new friends, in a real world where they don't have any. And in all that, all of us, a better life. In order to do that, we have to focus on the fact that these problems in the world, these problems that we have with each other, across this EVM even, these things that make us different, these sub-communities that split us apart, that we see disagreements in, those problems are what unite us. They're not what should drive us apart. This EVM, Ethereum, is what connects us together. And so you, as builders, building community, people, building apps across the EVM, across on-chain, an app is just something people download, but a community is something that you come back for. So what do? We have to realize and admit our mistakes when we have them. We have to realize we're not kings and queens. We're not royalty. Being in this space is a gift from the universe, but it's also a challenge. What am I? What are we? What are you going to do with this gift to be here today, to be able to fly here to Thailand, to be part of this community when others can't leave their own, to build something better? And there's a quote that's often cliche, but it's so true. Alone, we go fast, but together, we can go far. And so, in that vein, I set up just a Telegram group. So anybody here, there's no difference in networks. We're all part of this Ethereum community. If you'd like to be part of this Telegram, I'm an open book. People in our base community are open books. We're trying to build a better world together. Let's share our knowledge. Let's build a brain trust. People watching this recording later, come to this group. Let's work together. Let's go through the things that we can't talk about in a lightning talk. How do we build safe, secure communities? How do we scale communities? How do we make sure that everybody has their space? So thank you all for sharing your time to be here today.
Thank you so much, Will.
So,
any questions? Please raise your hand. I will throw this cube to you. Oh, there's one there? Oh, please help me.
It's not a question, but a word of gratitude. Thank you for your talk.
Thank you for your time.
highly need this kind of speech in the space. Like I just went out from a very different conversation.
Respect.
So thank you.
Yeah.
Thank you. I see another question over there.
Hi, Will. Nice to meet you in person.
Pura vida. Costa Rica.
How do you see communities like base Latam, base India, base Africa impact those communities?
I think that thinking about like how all communities start, they start small, and in time they grow. Some succeed, some fail, but if we think of things like on a cellular level, how human life imitates itself in the form of how we build communities. The ones that continue to get bigger and bigger and bigger, they divide and become their own communities. Taking Costa Rica as an example here, there's many builders in Costa Rica, but in that, there's also many people with differences. There's people that want to build on chain, that just want to play games, they just want to trade, they just want to work on infra. And a lot of those people, they don't want to have anything to do with each other. That doesn't mean they don't like each other, they're just not interested. So for us as community builders, it's important that within the first 10, 15 seconds when they come into our community, we're helping them get to the right place. And so in the context of this question for based LATAM, which we're referring to here, which is based communities in Latin America, it's continuing to build more and more smaller and smaller and smaller communities till eventually we reach the grassroots. So that's my answer to the question.
Thank you, Will. Thank you so much for your talk. I actually have a question, but I'll ask you later. It's about Web 2 user to Web 3. I'm interested in how you bridge the Web 2 users.
Thank you.
But thank you, Will. We will welcome our next speaker, Nine. He's the founder at Symmetry. And he will be talking about ecosystem development best practices, and he will tell us why you should start with the builder first. Stage is yours.
Hi, good afternoon, guys. So my name's Nine. I'm the co-founder of Symmetry. I'm also a fellow Thai here. So it's a pleasure for us to welcome you to my home country and my hometown, which is Bangkok. So really excited to be here. So yeah, straight into my talk. So as you can see from the talk title, it's about ecosystem development. So what I do at Symmetry is basically we help chains to onboard more builders and users from Thailand. So I figured this would be a good topic to touch on given Devcon. So what exactly is ecosystem building? So ecosystem building is basically a two marketplace, right? So side marketplace. So when you're building chains, you need both builders and users. And you need both at really strategic timings. A chain cannot function with one or another. So it's basically a chicken and egg problem. But actually, if you actually look at the data, if you actually go down and dig into the history and how each ecosystem came about, whether it's Ethereum aligned or not, out EVMs, whatever that may be, what's actually the key is builders, not users. And what I mean by that is, if you think about your typical user journey, right? When you try out new chain, why did you actually go to that new particular chain? Why do you actually go to Arbitrum? Why would you actually go to Optimism, Base, whatever that may be? Because maybe you went there to try a new flagship app, a net new application that you would like to use, which wasn't present anywhere else in another chain. These applications would then therefore define the chain identity. So if you think about Optimism, obviously the word public goods pop into mind. If you think about Arbitrum, probably DeFi. If you think about Base, probably consumer. But how do we actually onboard these great app builders? So we need to think about what builders actually want. What do builders want, right? So they want to onboard more users at lower customer acquisition costs, or CAC. And how can chains help them do that? So there's two ways. You either help builders onboard users directly, or you give builder more resources so that they can do more within that chain, which and effectively lower CAC from them. So how do we actually do that? We actually see two successful approaches on the chains that we work with. First, you onboard net new users or liquidity directly to the chain itself. A great example of this is Mantle. So what Mantle did, instead of going circle jerking around and onboarding the same set of users and liquidity, what they did is they partnered up with a firm called Alpha, and they helped onboard idle BTC liquidity on-chain by creating structured products around them, such as FBTC, which is quite interesting. And I think this is a good way to onboard net new liquidity into the chain, which is more helpful for builders. Another way is to do directed campaigns. So if you think about like a new chain launching out, you have all these new applications you can try on, right? What's best and optimal for both the chain itself and also the builders building on that chain is to help direct user activity onto these applications. So a good example might be Linear Park or even Blast Season 2. But if you go into that, there's also a couple of different frameworks on how a chain can actually support builders in a more hands-on manner. And you often see this sort of dilemma play out into different ecosystems that you see out there, especially the L2s. There's the curation approach and the education approach. For curation, you're just working with a select number of builders or select teams and just doubling down on them. And then on the other end of the spectrum, you have all these chains who are focusing on education, giving workshops, doing things across the globe. And the truth be told is, there's no right and wrong answer. It's more of a dynamic answer to this particular question. And it's important for a chain to double down on certain teams and builders to build those first set of great applications. And once you do that, then you transition out and then you onboard more builders. You become more inclusive. So you need to transition once your ecosystem matures. Some creative tactics. I'd like to highlight 3 here. So there's the Scout program, similar to AWS, if you're familiar. So you have other people giving out grants on your behalf, which helps provide reach. You have trickle-down incentives, like big bang competition to trickle-down incentives from the chain level down to apps. You also have retroactive programs like Optimism Retro PGF or Circuit Build to Earn to provide retroactive rewards for builders generating activity on chain. But what if my chain is pre-TGE? How do I fund these apps? What you can do is you can partner up with VCs to set up tokenless ecosystem fund structure, or you can curate deals, help your projects fundraise. You might not need a token. You might need to help them to find resources, find their network, and put these ecosystem projects out there. And to wrap it up, what about Southeast Asia? How do we actually penetrate this region? I would say 2 key things. Localization is key because you need to be aware about languages, cultures, and various differences. You need to have continuation. Building mind share is always filled with these noise from other ecosystems, chains out there trying to onboard more builders. So how do you actually maintain that spotlight in a continuous manner? You need to have consistency. And lastly, you need to allocate time to do proper due diligence with like the people that you're working with and the local partners that you have, because you have asymmetry information in language and whatnot. So that's also another thing. But all in all, the devil is in the detail, because ecosystem building is a multidisciplinary challenge with DevRel, marketing, ecosystem, and all that stuff. So you need cross-functional teams who constantly iterate. So yeah, that's basically it to the end of my talk. So just to wrap it all up, I just want to say thank you for your time for listening. Hope you learned a lot from it. And also, as a fellow Thai, welcome to Bangkok. Sawadee krap.
Thank you very much, Nine. Any question for Nine? Any interesting question about community building? Okay, thank you very much, Nine.
Thank you.
Let's give a big applause. Next, coming up, we have Yen Ho, and he has spent the last 6 years running the technical direction for runtime verification. And today, he will be sharing the challenges of building and maintaining the open source Web3 software. Please welcome him.
Good afternoon, everyone. I'm Yan He from Deep Learning. Yeah. It's fantastic to be here to share our journey of building Deep Learning. And hope our 3 years building experience could offer you some inspiration to build your local Ethereum community. Yeah. Especially with limited or even no startup funds. My presentation will cover 3 areas: Deep Learning introduction and its main components. Then I will work through our community governance, the rules that keep us organized and collaborative. Finally, I will show how we get grants in Web3 ecosystem and how we allocate our funds to support our community growth. Since the last Devcon in Bogota, I have introduced Deep Learning in detail, so this time I just quick recap the introduction. On the left side is our community-relevant data. We are designed for developers to step into blockchain dev development, where they can learn DeFi, NFT, DAO, and crypto projects. We could not only give junior developers a feasible and easy-to-use deep learning roadmap, but also present advanced developers with a platform for communication and cooperation. Yeah. This is our version. Our community is built on 4 components: GitHub, OSU, translation team, and website team. Let's start with our GitHub. Our initial idea was just to create a GitHub repo to record our learning trace of dev development in 2021. To our surprise, it was more popular than we expected. Currently, there are 80 basic tests that help you to learn DApp development step by step, along with advanced tasks like NFT, DAO, crypto, etc. Now we have garnered more than 5,000 stars and nearly 200 contributors have submitted their pull requests to our repo. What's more exciting, our repo frequently appears on the airdrop list of many Web3 projects. Next, we call it Deep Learning Open Source University. As many community members can schedule a session to share Web3 knowledge, as long as his presentation doc is reviewed and approved by our core contributor. We reward each session with 160 DAI through OSU. We have produced a wide range of courses, including a comprehensive DeFi learning roadmap and a ZK introduction course. Next is translation team. The world of blockchain is full of all sorts of temptation and scams. So it's essential for newcomers to study structured course from famous university. So our team have translated MIT open course blockchain and money. We also translated many white paper and research reports into Chinese too. As a local Ethereum community, we try our best to make high quality content from English word accessible to our core members. Next is our DAO governance. Governance are important to attract developers to build community trust and build community trust. There are 3 rules, interesting rules of our community. They are working well. Rule 1, anyone who has submitted PR 3 times or has shared at least 1 time can join our developer group. It has a ceiling of 120 people. We also build a community group for free communication too. If you want to make an advertisement in our group, you should share first. The last part is our grant and our fund allocation. As a non-profit organization, our funding primarily comes from grant and donations, like ESP grant and Gitcoin grant. In the midterm, we also get support from many outstanding projects teams, such as Optimism, Scroll, Starnet, ZK, etc. This year, airdrop from Web3 projects are also a big source of revenue for us. The financial module enables us to remain a technology-neutral stance. We only focusing on Ethereum and its layer 2 development without any commercial biases. The slide shows a support from, this is our fund allocation, you can see. We set up community grants and Web3 use grants to help developers transition from Web 2 to Web 3. This is our recognition from the industry. The slide shows the support from Layer 2 projects. Lastly, let me show our sponsors. Thanks for their support for our community. Thanks for your attention, and I'm open to any question you may have. Feel free
Thanks,
if you wanted to join us.
We have a question here. Do you want to throw it?
Good catch. Thanks for your sharing. And I think we all know building and maintaining the community is not easy. And deep learning definitely is a phenomenal success. And could you tell me or share your experience about what's the biggest problem or challenge during these years? I mean, in terms of education or the management,
That's a really good question. Let me think for a while. I think that the most challenging is the same as the most developer can across too, is the ZK technology. As you know, we have produced a course of DeFi learning roadmap. I think it's a good material for developers to learn DeFi. But we find it hard for developers to learn ZK or make ZK easy to understand for newcomers. So we still try our best to make it easy, accessible to everyone. Okay.
Okay, thanks.
Thank you.
Any other questions? I actually have a question for you. So for your users, I guess they're all geographically distributed in different places. Do you think there are specific designs that is more attractive to certain group, either age group or geographic locations? Do you find them tend to use, the app learning in different ways?
Actually,
the same?
Our users are mostly from Chinese-speaking areas.
I
Yeah,
see.
they're mostly Chinese. Yeah, most of them are developers. Yeah, because our content is more technical. You see.
Technical, right?
Yeah,
I see.
yeah. So, yeah, we try our best to make it accessible to non-developers too. But yeah, that's okay.
Cool. Thank you.
Thank you.
Thanks, Yan
Bye.
Ho. Okay, we'll take a 3-minute break and we come back at 4:20 for the next speaker. Welcome back. So we will be having our last speaker for the middle session today, and we'll have Average from Runtime Verification. He spent the past 6 years leading the technical direction in runtime verifications development tooling, and today he'll be sharing his knowledge on some challenges he faced in developing open source software for Web3. Welcome.
Hi. I'm Everett Hildenbrandt, as was introduced, and I'm the CEO of Runtime Verification, and I'm here to talk to you about the challenges of developing open source software and maintaining it sustainably. Not necessarily in Web3, it doesn't really matter, Web3, Web2. I mean, there's some different challenges in Web3, but a lot of them end up being the same. Why are we qualified to talk about this at all? We have, a huge GitHub presence, 170 public repositories, depending on how you count, 12 to 37 of them are active at any given time. It's spanning 15 different programming languages, lots of external collaborators, obviously the internal developers at the team as well. We have dependency chains within that software that run 6 deep in some cases, and we have different teams that range in size from 1 to 10. We've grown teams, we've shrank teams, we've done all sorts of different projects over the course of the last 6 years as I've been working at Runtime Verification. And we have super active and super awesome automation with CI and CD. So what are the challenges? I'm going to start from the easiest challenge to solve, which is the technical one. And a lot of people probably think, oh, this is the only challenge, the technical one. And with the technical challenge with managing open source software is automation. You need to automate everything. So you want to enforce as much as possible. We use GitHub for that. You can use GitLab or whatever other version control and publishing software you want to use. We use CI for testing, so every release is tested. That just keeps keeps us sane, basically. Automated releases and updates, and so we actually have it, when we have those 6 dependency chains going on, 6 deep dependency chains, if there's an update to one of our pieces of software, it automatically pushes down the chain to the next piece of software for us. And one of the kind of challenges that you might notice is, the software goes through different life cycles, right? When you first are developing a piece of software, you're in rapid development mode, you're prototyping, you're trying to move as quickly as possible, you don't want to be slowed down. And that looks a lot different than when you're in kind of the later stages of a project where you're just evolving the software over time and you have a lot more tests there to guide you. So you need to accept that there are different life cycles to software development, and for example, keep GitHub enforcement turned off at the beginning of the development, and then a couple months in or a couple weeks in, turn on that GitHub enforcement. The second challenge is personnel, and this, maybe it even deserves to be the third challenge, because this is the medium difficulty challenge. But what I like to tell new hires at Runtime Verification is that learning to program is easy, learning to program in a group is hard, right? And the key thing to remember is that you have to be respectful of other people's time, right? And one thing to keep in mind is it's always harder to read code than to write code. And so you're submitting code changes or something like that, and it was easy for you to read it because you have the intent in your mind and you translated it into code. It's much harder to go from that code and translate it back into the intent as the PR reviewer. So as the person who's authoring code, you need to make sure that your code is small changes, isolated changes, easy to read, well tested, so that the PR reviewer has an easy time pressing the approve button. Remote work obviously makes this a lot harder. When you're all in the same office together, you just turn around, hey, what do you think of this change? And you work on the same screen. But now we're talking about different time zones, and there's delays associated with that, so you have to keep all that in mind and actually keep it in your mental model for your development. And so here, process is key. Example, at Runtime Verification, I let everyone know, beginning of your day, you clear your Slack messages first, then you do your pull request reviews, and then you do bulk code development on new code, and then you open new pull requests at the end of the day. You do your pull request reviews first because that's blocking someone, right? That is causing a synchronization point between you and someone else. They might be on the other side of the world, and suddenly, if you don't do that pull request review, you're delaying them by a day, and then that maybe delays you by a day. And so suddenly, some small change gets delayed 2 days, maybe 3 days. If we're talking about an 8-week project, and you have a handful of delays like that, you've lost 2 weeks on that 8-week project, right? It's not good. Anyway, next slide. The third challenge is money, and if you know how to solve this, please let me know. The solution I found is to beg, and the problem with begging is that everyone starts begging, and you need to have like a begging process and have a little structure to it. And so you have like grants and retro funding and side quests where you get people to fund one thing, but then you develop another thing as well. And the problem with structured begging is that it becomes a game. And big players are better at games than small players, and so then the small players resort back to unstructured begging, and so, I don't know, we're back at square one. So Anyway, that's my talk. Solve the technical challenges first, prioritize those, that's the easiest part. Make sure as you onboard people that you make them aware of the personnel challenges, and then come let me know when you figure out the money thing. Thanks.
Thank you. Any questions? Oh, there's one here.
Great presentation. I just want to know more about runtime verification. I just check in the website, but it's much better for you to introduce what you do and why are you working on open source?
Yeah, so we do mostly formal verification and formal verification tooling. So we have this project called the K Framework. That's kind of our biggest project. That is a tool that enables us to do formal verification for any programming language, basically. And so we have formal verification tools for Solidity, for WebAssembly, for Rust. We also have for some other blockchains like Cardano and Tezos and stuff like that. So that's a big, formal verification is hard software to develop, and it's used in a bunch of other contexts as well. And so we just end up having a lot of different repositories targeting different ecosystems and different programming languages that we do that for. And most of that is done for security audits, basically. So,
thank you.
Mm-hmm.
There's a question over there.
Thanks. Hi. Because you already mentioned the workflow, especially the GitHub pull requests. So I had a question about that. Do you have any advice in terms of leading the team and structuring the PR reviews? Because in my opinion, when there is an update or is a bug fix, it's quite straightforward. It doesn't really matter the number of commits, because you look at the change, you look at the description, you know kind of what's happening. But perhaps you have an advice on how to structure the commits when it comes to a new change. And when you said about it's hard to construct the intent by looking at the changes. So perhaps having more commits and following them one by one would help with that, or you know what I'm asking?
Yeah.
Perhaps have it up there.
I mean, it's challenging, and it's challenging not because it's a non-solved problem. It's challenging because people just don't do it, right? But have good commit hygiene. I try to make it so every commit builds, if not passing tests. It might be that you're going through refactoring and tests have to be failing in the middle there, but every commit should build, in my opinion. And so that should make it so every commit you can review in isolation if that's necessary, which is not the ideal way to do it because that takes a little longer to review. But then the second piece of advice I'd give on that is, as a pull request reviewer, just be really picky. If someone sends you a pull request that is changing 4 different things and it's hard to review the whole thing and keep it all in your head, don't bother reviewing it. Just send it back to them and said, hey, you weren't respectful of my time. Break this into 4 pull requests and I'll review each one independently. Because ideally, as the pull request reviewer, it's easy for you to look at a pull request and say, this is a good change. I'm going to hit approve and move on, right? But if you can't do that and you have to now dissect what is this change doing, you're not the expert on it. You didn't write that code. It's much easier for the person who authored the pull request to go and split that up into multiple different pull requests than it is for you to dissect what they meant, right? So don't, as a pull request reviewer, don't be shy. Just be like, look, be more respectful of my time, please. Go break this up into multiple pull requests so I can review each independently. That's my opinion on it.
All right, thank you very much.
Thanks. Thanks for the tips for PR reviews. I think we can all benefit from that. That's everything for this session. Let's give another applause to Everett from Runtime Verification. So we will take a 30-minute break. For the last session, we'll have 9 speakers giving the last part of the lightning talk. So we'll be back at 5. And the day ends at 6:30. So hopefully you have some break, and we'll see you soon at 5 o'clock. Welcome back, everyone. This is our last session of the lightning talk. So we will have 1.5 hours with 9 speakers giving different talks. So let's keep the energy going, and let's kick off with our first speaker, Pablo. Welcome, Pablo.
Hey, how are you guys? How's everything? Well, today I had a workshop, but they told me, okay, you don't have an hour, you have 5 minutes. So I'll make it brief, and I'll go to the conclusions. Well, I'm Pablo Sabatera. I do Web3 operational security at OPSEC, where we train and audit companies for everything that is not a smart contract. And I am a contributor of SEAL 911, where we do incident response for blockchain. So what are we going to talk about today? Simple things that we can do to enhance our OPSEC, right? So one thing that is very important to know is that it's not so important if I use Windows or Mac, Android or iPhone, Chrome or Safari or whatever. The important thing is how we configure the tools that we use, right? So first thing I want to talk about very fast, two-factor authentication, things that you not have to do it with SMS. And we cannot do it anymore with TOTP apps like Google Authenticator or Authy. Those kind of 2FAs can be phished, and they're being phished every day. We need to use YubiKeys, right? But not the YubiKey with the normal OTP mode. YubiKey with FIDO2, that cannot be phished. This is happening a lot in the ecosystem. Next, social engineering. We have to be very, very, very careful for this. Like professionals hack people, not systems, right? Today it's much cheaper to attack someone and much easier than to attack a system. So be very careful with supposed recruiters, VC funds, investors, and journalists that want to invite you to some call or something. Never download anything. Be very careful with PDFs that you open. They are usually infected. And if something looks like strange, it's probably a scam, right? And everything is a scam until proven otherwise, everything. Next, eventually all of us will get hacked. That will happen. It's not a matter of it will happen or not, it's just a matter of time. So we need to be able to contain the damage so that you know when someone in your team has been hacked, the damage will be contained. Even the founders, even the CISO, even the CTO, everyone. Use an antivirus and a firewall. People think that, no, I use a Mac, I don't need an antivirus. Use an antivirus. MacBook is not good with virus alone. There's a good foundation called Objective-C that has many tools for security in Mac. One more thing, the attack will come from a trusted source, right? For example, we saw how they were hacking the Eventbrite of the events at Devcon 1 hour before the event, and they send a message from the real account to everyone, hey, you have to mint this NFT. You mint it, your wallet is drained completely. You receive an email that says that it's from Trezor, and it's really from Trezor, from their official system, but it has been hacked. They send you a drainer, you are done. One more thing, use a password manager and never, never, ever reuse a password, right? But let's use password managers, and we have to have them configured very securely, but never, ever, ever, and this is very important, never put a seed phrase in a password manager, right? For sure, many of you have done it, yeah? And you say, oh, I did it, but it's okay, my password manager is secure. No, it's not. If you have ever put a seed phrase in a password manager, you cannot use that wallet anymore. You have to move to a new one. Use hardware wallets. Hardware wallets are important. Many will think, okay, these things that this guy are telling us are very basic. This basic stuff is the reason why today 85% of lost funds are lost every day, right? In blockchain. It's not anymore due to smart contracts. We have gotten very, very good at security with smart contracts. And money is being stolen like this. So you have to be really, really careful. Well, I hope you liked it. I will be here if you want to talk more about this. Like, this was a very, very, very small resume, but operational security is important. It's the #1 reason how we are being attacked by very sophisticated threat actors. Something that is happening is that In the industry, we have one of the worst OPSECs in all the industries worldwide because we don't have regulations, so any company does whatever they think that it's okay, and it's not. And on the other side, we have very, very sophisticated threat actors from nation states that are doing these kind of attacks, and they know what they're doing. So be extra, extra careful. I hope you liked it.
Thank you, Pablo. Any questions for Pablo?
Yep.
Oh, there. Do you want to give it a go? Because it's on your side. Do you want to throw?
I had to throw it there. Okay. Oh, sorry.
You're much better than me.
So what would you recommend to people to store their seed phrases securely? Because I think the challenge is, I mean, I'm a CTO as well. You either have to make it secure or if you want to prevent people writing it down on a post-it note, right? So what
I think that writing down seed phrases is one of the best ways to store them. One hack that you can use that is very, very simple, was told to me by one of the guys from the Red Guild, is buying anti-tampering bags, the ones that e-commerce use. So you write it there, and wherever it is that you save it with that. So with that, you are sure that it has never been seen by anyone. If sometime it was seen by someone, they have to break that. So that's another very good way. And I really like Shamir, like having your seed phrase and cutting it in places in 3 lists, but you need 2 of those 3 lists. That gives you confidentiality and availability. So I think that's pretty good.
Thank you.
Do we see any other questions? Oh, over there.
There was one question. Yep.
All right, I actually wrote down my question. How do you choose a product for secrets like SSH keys, OAuth tokens, etc., management across multiple cloud providers?
So a product or what, sorry?
A product for secrets management like SSH keys, OAuth tokens, across multiple cloud providers.
I don't have a good answer for that, so I'm not sure what would I use. The guys that are really, because I only talk about stuff that I'm really, really good at, right? And the guys from the Red Guild had a very good guide on that, so they will be maybe able to ask that question far further.
Thank you.
Than me. No, thank you.
What do you think? What is the more secure, multi-sig wallet or hardware wallet?
No, I think that safe is good, and regarding hardware wallets, I consider that all of them are also very good, Trezor, Ledger, SafePal. The thing is how you use them, right? But I think that all of them are very good, and I think that safe is also very, very good.
Yeah, there's a question over there.
Right. You covered a lot of stuff there, but is there any advice you give on browsers or how you deal with browsers? And that's generally where a lot of stealers are sitting or whatnot.
Yeah, browsers, be very, very careful with the extensions you download. Like, we have to be very, very careful with extensions. There are lots of malicious extensions. And the other good practice is to have more than one session. For example, you use Chrome, you have 5 sessions, one for work, one for DeFi, one for personal stuff, one for this, for that, for that. And you also can have another browsers, right? Or even better than that is having another session in a VPN, right? So you have it, in a virtual machine. So you have another virtual machine with another browser if you want to keep it like really separate, and that's also pretty good.
Okay, thank
you
you
very much,
Pablo. Our next lightning talk will be from Jason. Jason will be showing us how to secure your secrets with Microdot. Let's welcome her.
Hi guys. Waka.
Just joking. Welcome to Thailand. Okay. For my talk, I'm going to talk about Microdot. So what exactly are microdots? So I'll be talking about how do you, like why microdots and how you can actually make them. And I have some samples, so after the talk you can check it out. So I guess there's a lot of questions about OPSEC and how can you hide seed phrases? And so a lot of the processes are all digital, but what if there are physical processes if you can obfuscate stuff? And so key custody remains like a huge problem. And so there are like secret sharing, social recovery practices, but I know a lot of crypto people are incels or hikikomori, so like social recovery might be hard. So look at this graph. We have the holeless epidemic that is happening right now. So yeah, key custody and like social recovery is going to be a huge problem. So what if there are physical approaches of obfuscating information? And so this is one of a steganography technique, and it's called microdots. And so the reason why I'm showing out this Anya Forger today is because this has historically been used in espionage and spies. And so the goal is to essentially hide messages in plain sight. So how do you do this? So apparently all the documentation around this is so limited. So you try asking Claude, it's like saying, sorry guys, no info for you. So I was like trying to reverse engineer this information myself, and basically the slides are gonna document everything. I won't be able to cover everything, but I'll cover through some interesting details. So we are gonna revive analog photography for this use case. So why we want analog processes? There's basically no chance for someone to hack like an analog camera unless he steals a camera from you. And there are a lot of gotchas, so I kind of screwed up so much, and I can't talk everything in details, but I'll create a GitHub repo documenting the processes. So one of the main issues with analog photography is this thing called ISO. So on your cameras, like this is not a huge deal, you can adjust it. But ISO is a function of like the film grains. And so this becomes a problem of how much you can miniaturize an image. So the smaller the ISO, the smaller the grains in general. And so this is like the few processes that you will need to do. First you need to take a photo, and then you have to develop a photo and then fix it. And that's like the first phase. And so we'll be talking about two phases. So the second phase is, instead of expanding the image, we want to do the opposite. Okay, so these are all the things that you need to use. Oh yeah, so this is kind of interesting. So I have like two processors. One of them uses ammonium dichromate, so I call this cancer orange. So I probably need to go for cancer screening after this, because I think I might have breathed in some dust from this. Yeah, and then there's like cellophane. So this is like dialysis tubing. So I was like going to a medical store. I don't have diabetes, by the way, but no, I don't have kidney failure or diabetes. But you need this to kind of, as a substrate. Okay, a bunch of optic stuff. So this is how you do it. You write your seed phrase. So normally in MetaMask, you ask you to write a seed phrase, but then where do you put the seed phrase? So this is one way you can store the seed phrase. You take a photo of the seed phrase, roll in the film, develop the film. Oh, and also one interesting thing. Apparently, these are all heavy metals because they're silver metals. Like you shouldn't pour it in your toilet. So I accidentally poured some in my toilet, so I might have committed some offenses around here. Yeah, it will probably corrode my pipes in the worst case, but I might have caused some like environmental hazards. Yeah, so the next process, you take the photo again, and then ta-da, you have this tiny little boy over here. And so this process where you retake the photo again is called the British process. And the next other process which I want to do was like a dichromated process. And this is how you can get like microscopic minifications, like 1000x. And so the goal is to find a chemical substrate for this. And so this is where the forbidden orange juice comes in, and it's very toxic. Do not breathe in or use this chemical. So I'll try to find like a better chemical for this, but most of the photosensitive chemicals are toxic as hell. Yeah, and this is like the process. So I did spill some of it, and so I almost died. Yeah, and so this is how it works. You project the image, and then you get this tiny little thing, dots on this piece of paper. And that's it for this presentation. I'll share more details on the GitHub repo if you guys are interested.
Thank you, Jason. Very cute hair. Any questions? Okay, I'll do the easy one.
How do you do this whole process without getting on the FBI list?
I'm probably on the list right now. So I guess you need fake IDs or...
Got it.
Okay, another question.
Did you consider anything else?
Oh, I did consider like other steganography techniques, but I think things like microdots have historically been used, but I somehow do not see them around in practice today. So it could be the case that it's all classified. So I'm like, maybe you're leaking classified information right now. So.
Well, I guess my follow-up question to that is there were other methods used for espionage throughout the world wars that might have been easier to do.
Yeah, it might be classified. So yeah, I couldn't find much information about this, unfortunately. So I was just reverse engineering the chemistry. Yeah, instead of code, it's now chemistry.
I think we have a question at the back there.
So why are we not using photolithography for it?
Photolithography. Oh yeah, it's basically a similar technique. So, but not everyone has a clean room in their home. So the goal is to find processes that you can do in a home environment. So it's kind of similar to photolithography techniques. So some of like the techniques are applicable. Yeah, but also like photolithography, also some processes are patented, so you can actually like use them in practice.
Cool. Any other questions? There's one over there. Can we throw? Is it in the middle there? Oh, no. Sorry, you raised your hand, and I thought you want to catch up. Okay, there's another question there.
How small are the microdots?
I can show it to you later. It's quite small. That's all I can say. It's like small.
So you definitely need a microscope.
The one using the British process, you can see if you're with a naked eye. But the other one, it's kind of really damn tiny. So I'm not even sure whether it's like an actual image or not. Yeah, I need a microscope for this.
Great.
You do have a question.
And how long? Hi. And how long does it stay? Is there like a half-life?
Half-life, this is not radioactive.
No, but what I mean is like, does it? Can you see it after like 20 years, for instance?
We'll find out in 20 years.
Okay, one more question over there.
Hello. Have you reversed the process, meaning you encoded? Have you blown up the picture to see if you can recover it?
I think you could. You probably need some kind of optical setup. So essentially, you're trying to project an image.
Okay, we're running out of time. That's the last question. Thank you very much, Jason.
If you guys want to see stuff, I'll be somewhere around here. You can see some of the samples. Thank you for your time, guys.
Thank you. Our next speaker is Peter. Peter is the CEO and co-founder of L2Beat, and today he's going to show us some new feature of L2Beat, which will allow you to see the protocol risk you are exposed to as a user. Let's welcome Peter.
Let me tell you a story. And you're probably familiar with it. You might have even lived this story yourself. A young guy, like you or me, decides to bridge their tokens. They take out their hardware wallet, connect it to a computer, go to the bridge website, and now they start sweating, right? Because they're bridging. They don't know what's going to happen. They make a transaction, and the coins don't appear on the other side. What's going to happen? What's going to happen? 10 seconds pass. Oof, the coins are on the other side. The guy's saved, right? But actually not, right? And that's the funny thing. We think that the only risks that we are exposed to are during the bridging. And then we don't really think about the tokens that we get on the other side. And so, for example, for bridges that lock and mint tokens, the tokens can still be stolen on the original chain. And for bridges that are liquidity networks, well, they still have to give you a token on the other side. So this token still might be stolen. And, you know, we were sitting half a year ago in Budapest at an offsite for L2Beat. And we were looking at our website and thinking, you know, those risks that we show, they are really nice, but they aren't really connecting with some people. Because they see what we show. They can see, oh, Arbitrum this, Optimism this. So they can go dig deeper. But it's not personal for them, right? They don't have an ability to see the actual things that they are exposed to. And when we thought about how to solve this problem, how to make something that will actually allow users to see the risks they were exposed to, we actually figured out that this thing would have to be for a different target user, and it would have to look completely different than L2Beat today. So what I have for you today is a thing called Insight. And what Insight is currently a demo that you can see on our booth. But what it is also, it is a way to see the risks for your specific wallet. So if you were to input your ENS address or your your ENS name or your Ethereum address there, you would see a list of your tokens that you hold on different chains with the associated risks. So now you no longer have to go to the L2Beat main page and figure out, oh, is this chain where I actually have my tokens? Is this bridge the one that I have used? All this information is compiled for you. And what we also show, right, on the Insight is the path that the token has taken through the different blockchains. So you can actually see that the WBTC you're holding on Arbitrum 1 has been bridged from Ethereum. But before it got to Ethereum, it has been locked on Bitcoin. And there is a multisig on Ethereum that some permissioned custodians manage that actually takes care of those tokens. And we hope, this is an experiment that we're doing, but we hope that maybe this will allow users to feel that the risks are actually affecting them, see what risks they're actually exposed to, and we're also thinking maybe we can suggest some mitigations. One example would be that you might be familiar with would be the USDC-E and USDC tokens, where the USDC-E token is the one that was bridged from Ethereum, while the USDC token is the one that's bridged through CCTP or CCIP, the bridge from Circle itself. So one has an additional trust assumption, the other doesn't. And I encourage you very much to go to our booth, check out the demo, play with it, and thank you.
Thank you very much, Peter. Any questions for Peter? L2Beat? I actually have a question because I use L2Beat a lot. Are you going to include MEV data on L2Beat?
Oh, that's a very interesting question. We haven't been exploring that side very much. I think it very much depends on the progress that the chains are going to make. Because the more progress the chain makes, right? For example, right now, most of the rollups are stage 0. There are a few that they are stage 1. And at those stages, the thing that actually matters is the fact that the owners of those rollups can just upgrade it under you and just take all the money. So the MEV is like a detail, but it matters way less. If we start seeing a future where rollups are more and more decentralized, then those topics would become more and more important because we can stop focusing on the trivial stuff. And I think this will be a good point to start looking into this.
I see. Thank you. It's a question.
Hello? Are you planning to incorporate any notification of scams after they happen in real time for specific bridges?
That's a very good question. I think this is something that we would like to do, right? It's very hard to detect this because you never know what exactly is going to happen. We have a monitoring infrastructure, but it's still, I guess, run every other hour, so it's not in real time. Maybe in the future, our internal tooling would be sophisticated enough that we can, detect those things in real time, and then we would maybe send notifications. That would be really fun.
Do we have another? Oh, there's another question there. Oh, there first. Sorry.
So right now you are only detecting famous dexes, or like any dex that will just pop up and someone breaks through it?
In terms of what we show from the risks, right? At L2Beat, we analyze the L2s. Not all of them are just dexes. Some of them are just general L2s, meaning they can execute any EVM code. And for the tokens, we actually look at other risks, for example, the bridge risk. So it's more than just dexes.
Okay, one last question at the back. The gentleman there.
Yeah, I think of this similar to tools like Revoke Cache, where you would manage your allowances. So what's the original goal? What was the original intention behind building this? Like, what risks are you mitigating?
Yeah, the main intention is to make things personal, right? When you go to the L2Beat website, the things you see are very technical and also very specific to the projects, right? And with this demo, you can see the actual things that affect you without seeing all the rest, right? So the intention was to cater to a different type of user that doesn't feel the connection with the main website that we have.
Okay, thank you so much, Peter.
Thank you so much.
Good to know these new features from L2Beat. Our next speaker is Polina. Polina is a researcher from Runtime Verification, and she'll be showing us a playbook of secure smart contract development. Let's welcome Polina.
Hi everyone, I'm Polina, I'm from Runtime Verification, and today I'm going to present our comprehensive approach to security that we have at RV, because I believe that it can significantly improve the security stance of projects and even make it more sustainable for them. I'd like to represent this project as a pyramid where lower layers enable, or at least make it easier to get the higher layers right. And currently the standard is to implement the code and just hand it over to some external auditor or a contest for a one-off audit or code review. And while it is a pretty good baseline, it also doesn't do much in terms of continuous security assurance. And that is very important, especially for protocols under active development. If the team has resources or feels like it, some projects also have some documentation outlining what the code is actually supposed to do, or even use some tooling to do unit testing or fuzzing. And while the completeness of those is very much hindered by the constraints in the development process, having more complete documentation and some tests actually helps make sure that the audit is actually going to go well. because it adds an additional dimension to it, since the auditor can not only check for some common vulnerabilities, but also for the adherence of the code to the business logic that they're supposed to implement. And having tests obviously is good too. A more comprehensive approach, however, adds some more layers, and maybe counterintuitively, we actually think that it makes the security model more sustainable. And one of the steps that is often overlooked is the design review. That's where some person, an auditor, looks through the design, understands what the project is actually supposed to do, and how does the architecture looks like, and sees if it actually makes sense. Because if the design doesn't, then none of that matters, actually, because the protocol can still be compromised. And the good byproduct of that is that it also allows you to write better properties and specification outlining what the code is should or should not do. And once formalized in the forms of tests or proofs, that actually enables the application of more advanced tooling. We can have more complete fuzzing test suites, we can do formal verification for even better security guarantees, and the best part of that is that we can also run them on CI. And I genuinely believe that having automated security processes is good. Adding more automation is better because it makes it harder to just skip through certain steps. It ensures that the security protocol is actually followed consistently. And also CI, in that sense, works as sort of an automated audit that is going to be run on every PR or every commit. Well, that's less expensive than having a human look through it over and over again. So as an example of something as an example of how it is important to follow through this whole process, I have this example that may or may not be based on a recent hack, and that happened to the protocol that helped users convert their BTC into an equivalent amount of wrapped BTC that we'll call Devcon BTC. And it was running on BTC chains, so it was supposed to work with native tokens, but it was also running on other networks which had Ethereum as a native token. And there was a change that actually made it possible for users to mint an equivalent amount of Devcon BTC for Ether, and Ether is like 20 times cheaper. So the hacker actually just minted a lot of free money, basically. And the thing is, there was a property that just hasn't been enforced, or maybe hasn't been formulated, that the user should also not be able to convert non-BTC tokens into, the wrapped version of BTC. And this property could actually have been enforced with something as simple as a unit test or this fuzzing test that you can see on the slide that just checks that if the protocol is running on Ethereum mainnet, then whenever someone tries to mint tokens using Ether, this transaction fails. So that is a foundry test. Has it been running on CI? It maybe could have caught the issue as soon as this code was pushed, but before the deployment. So to summarize, the points I want to make here is that security is complicated. I think everyone knows it. There are a lot of steps in this process. It's very important to get all of them right. Automation is very useful because it helps ensure that the security process is followed consistently and is enforced. And in addition, CI also provides a very efficient and a very cost-effective way to ensure that new updates don't break anything. One last thing that has been missing so far is this base layer, which I haven't really touched in detail, that is OPSEC, because unfortunately there have been a lot of private key compromises in the past year, and if the private key is compromised, then unfortunately even a very secure smart contract code can also be exploited. And there are a lot of resources about how to get it right on the internet, so I encourage all of you to look through it, and yeah, thank you very much.
Thanks, Paulina. Any questions for Paulina?
I guess my one question would be around maybe fatigue in terms of continuing to be diligent about making sure that the basics are in place. And I'm curious for you what has helped to maintain those habits over time.
Thank you. Yeah, we try to follow these processes religiously at RV. Automation helps a lot because you don't have to, go over the same things over and over again. Instead, you write some properties that you specify some properties, and then you formalize them in the forms of tests or proofs with a lot of formal verification. So that's what we try to set up. And then whenever code changes, that actually handles it for us to a large degree. I think it actually, having the process makes it easier.
Cool. Next
Hi. Yeah, question on blockchain security, where you have smart contracts, which is immutable, versus, let's say, on Web 2, where you can update your code if you discover a security problem after the fact. So how does that factor in?
Oh, you mean upgradability?
How would you, not necessarily, but like, let's say you don't have upgradability, then how would you modify your security practices such that that doesn't, so that you mitigate that, I guess?
Right, got it, thank you. Well, I guess that's why you try to get it right the first time before deployment. That's why we advocate for a very comprehensive security analysis that you perform before deployment to make sure that you go through all the stages, that the team writes proper documentation, helps us formulate the properties and invariants that should hold, that can later be monitored. We advocate for formal verification to ensure that there are the best security guarantees. I guess there are some. There is a field that deals with some post-hack things or recoveries, but I guess that's a different story. We just suggest that people should get it right, and I think we're getting better.
Cool.
Is there something like the OWASP Z-Attack proxy equivalent in smart contracts or blockchain frameworks that you'd recommend?
Sorry, can you please repeat once again?
The Open Web Application Standards Project, the Z-Attack proxy that they have. We used to use it in our CI tooling in Web 2 sort of development to test for the top 10 OWASP security vulnerabilities.
Right, yeah, I haven't been aware of that, but it sounds pretty useful. I'm all up for using any tooling that helps and having it on CI. I guess anything would help. Static analyzers are great. As the first step, especially. Having unit tests is also extremely helpful and very efficient. Fuzzing can uncover a lot of vulnerabilities. So yeah, thanks for letting me know about that.
Okay, one more question.
Thanks. You mentioned a designer review as a precursor to the actual code review. Is your hope or expectation from an audit point of view that a team comes to you with the design before they even write the code, or were you just talking about that as a specific phase of the audit?
That is perfect, but that almost never happens. Okay. So the sooner we introduce security and some testing, any of that, into the process of development, the easier it becomes for everyone. That's something that we have found out ourselves, but it almost never happens. So we at least try to allocate some time for design review first before we dive into the code itself to make sure that we also understand what it's supposed to do. But I mean, having the team providing us the design first is ideal, and we can also help out with the stages, but it's pretty rare because of the resource constraints, I guess.
Great, thanks.
Okay, we can take one more question, if there is any. There's one there.
Thank you. I'd like to know if there are some security best practices for smart contract based on artificial intelligence. Thank you.
Based on artificial intelligence, right?
Yes.
Right. I am aware of a few tools that do it. I think you can also ask ChatGPT to generate you some security practices, and it will be pretty helpful when it comes to common vulnerabilities. I guess the current common problem with all this AI-based tooling is that it is good at pattern matching, right? So it can definitely help you find some common issues that are known for a long time, but it probably has bigger issues with business logic or design review parts. So I guess it's pretty helpful, at least when it comes to the first part.
Okay, that's everything. Thank you, Polina. Let's give it up to Polina. Our next lineup is Jack. Jack is the co-founder and CEO of Sherlock, and he's going to share with us what's the most common vulnerabilities found in audit contests. Stage is yours.
Hey everybody, great to see you all here. Thanks for coming out. I'm Jack Sanford. I'm the CEO and co-founder of Sherlock. Sherlock is one of the largest audit contest providers in the space. And today we're going to talk a little bit about the most common bugs found in audit contests. So if you're a protocol developer or if you want to become a protocol developer one day, you are going to be ahead of 90% of other protocol developers just by being aware of these 10 common bugs. So just a quick intro on audit contests and why you should care. Audit contests have become and are becoming one of the most popular ways to secure smart contract code before deploying a protocol to mainnet. There's been 625 audit contests run. The most have happened this year of any year, so it's really taking off. 36,000 vulnerabilities found. 36 million in prizes have been paid out to thousands, tens of thousands of security experts, people who are learning to be security experts, all from finding bugs in these audit contests. And as you can see, the biggest teams in the space are using audit contests. All of these teams have done an audit contest this year in order to secure their code. So what is an audit contest? Essentially, the goal is to find bugs in code, usually critical bugs, bugs that are going to cause losses for users on mainnet. You start with a pot of money. You say, hey, here's 100K, or in some cases, here's $1 million, and we're going to pay people based on the bugs that they find, and anybody can participate. So it's a really great way to onboard to crypto, really great way to onboard to Web3 security, participating in audit contests, and depending on the severity of the bugs you find, so if they're critical severity, you're going to get paid more for them. If they're super unique and other people don't find them, you're going to get paid more for that. And if you find 3 of the 4 bugs that are in that protocol during that audit contest, you're going to get paid a lot of money for that. So really cool thing, and we're going to rip through super quickly the top 10 vulnerabilities that are found in audit contests these days. So number 1, first depositor inflation attack in ERC 4626 vaults. This is a super famous attack, really annoying because anytime you deploy a new vault on a blockchain, you're essentially exposed to this attack because the person who puts in the first deposit can essentially put in such a tiny deposit that it causes sort of a rounding issue, and then all the deposits after that are a little bit messed up, and the first depositor can steal funds that way and kind of DOS the vault. Second one, using transfer instead of safe transfer. So just using the transfer function in Solidity doesn't actually check the success or failure of a transfer, and it can also allow for really bad things like reentrancy with non-standard tokens such as USDT. Number 3, missing validation and admin checks. So let's say you only want the owner of a contract to call a function or someone on a whitelist to call a function. A lot of times there's so many functions you just forget one essentially, or you forget to check for something that you meant to check for, and that's what auditors are here for, and they're really good at finding that stuff. So this happens more often than you'd think. Okay, missing check for active L2 sequencer. So essentially, if you are deploying a protocol on top of an L2 like Arbitrum or Optimism, sometimes the sequencer goes down. Not very often, but it could happen in the future, and it could happen for long periods of time. And if you're a derivatives protocol or something where real-time information is super important, malicious actors can take advantage of stale prices because of the sequencer being down. Number 5, the classic reentrancy, very first major vulnerability ever in Ethereum, the DAO hack. Basically, there are certain functions where essentially you can continue the execution outside of the function and call that very same function again, and this can cause all kinds of problems. There's a bunch of different surface area for what these vulnerabilities can do, but I'm sure a lot of you have heard of reentrancy already. Beyond transfer, rebasing tokens. So if you want your protocol to be able to handle any token out there, or even a pretty general set of tokens, a lot of them are non-standard. A lot of them don't conform to things that you would think that they conform to. And so smart contracts can get completely DOS'd or funds can be lost because of these tokens having non-standard behavior with your functions. So rounding, precision loss issues. This one has become really famous in the last 12 months. Even if something is off by a couple of way or to the 18th, 17th decimal place, you can have major issues because of the way that Solidity essentially, or the EVM essentially doesn't have floating point arithmetic, so it truncates things, it rounds things a little bit, and that can cause a lot of issues. Hitting the last three really quickly here, using spot price instead of TWAP and Uniswap. So this is something that I think we've all seen, price manipulation attacks where someone basically inflates the value of a certain currency in a Uniswap pool for even one block and then does some attack using a flash loan and then it goes back down. So that one is really common, less common these days, thankfully. Incorrect implementation of upgradability. So essentially you want your contracts to be able to be upgraded, and it turns out you hard-coded something in an initializer, you hard-coded something in the constructor, and you can't actually upgrade your contracts, and you only find that out later. So that's kind of annoying, but not too big of a deal unless unless the initial deployment of your contracts is super critical. Last one, no slippage check in custom vaults and pools. So ERC 4626 is great. Use standards whenever you can when you're developing in Solidity. Because if you have non-standard pools, you can actually have your user sign up to get a trade done at one price, and then at the very next block or the very next execution, that price is completely different, and it can be off by a massive amount of percentage points. So your users can get really into trouble if you don't have slippage checks on your functions there. So that's the whole talk. If you're looking to become a protocol developer, check on these 10 things before you send your protocol to audits, and you'll be ahead of 90% of the other developers out there.
Thank you, Jack. I see a question over there.
When would you do an audit contest? Would it be like after you've done an audit or before you do your first audit, or instead of a regular audit? What's the goal there?
Yeah, it's a great question. If you can do multiple audits, I would normally say do the audit contest last because you get 300 people. It's a little bit, there's more operational complexity with it because you have to deal with 300 people. Sherlock and others will deduplicate the issues for you. So if you can do a traditional audit or two before that, that's even better because you get to have kind of consultation with somebody and really fix a lot of the things early on. And then when you're like, hey, I think this thing's ready to go to mainnet, do an audit contest, and you'll find all the other stuff, essentially.
Great.
That's the goal.
Hi. Are there any standard protocols or platforms for holding these contests that you can recommend?
Yeah, so I'm the CEO, co-founder of Sherlock. Sherlock is one of the main ones, so I'm obviously very biased. But there's Sherlock, there's Code Arena, there is Immunify does them as well now. There's a platform called Cantina, CodeHawks, Hats. So there's a few platforms out there.
Thank you.
Any other questions? Oh, we have one here.
Thank you. Audit is very expensive. So what is your suggestion for small debt with very tight budgets? Thank you.
Yeah, if you have a tight budget, I would say just try to keep your contracts as simple as possible. Every line of code is going to cost you money when it comes to the auditing phase, and you really want to pay per line of code. Like essentially, you need to pay for the best people because those are the people who know how to hack contracts, and those people exist on the black hat side, like the bad guys. So you need to make sure you're paying for the best good guys as well to ensure that you find those vulnerabilities before you go to mainnet. So if you're kind of bootstrapping, just try to keep your code as small as possible, as simple as possible. Use other code that's already been audited if possible. And when you actually do an audit, don't go for the cheapest provider because you really want to get that top talent, even if you have a small code base.
Okay, that's it. Thank you very much, Jack.
Thanks a lot, everyone.
Our next speaker is Om Shah, and he is the co-founder of WalletGuard. He's going to show us a history and the evolution of scams and showing us new techniques to combat them. Let's welcome him.
Hi, everybody.
my name is Ohm. I was previously one of the co-founders of WalletGuard. Now I do security R&D at MetaMask. Today we're going to talk about the evolution of scams throughout the crypto space, specifically pertaining to end users. So let's start with some of the OG scams in Web3. First off, we have our enter your seed phrase here scams, your typical seed phrase stealers when you end up on a phishing website. You also have those send your money here and we'll double it. I'm sure everybody has seen this across Twitter or some of these other platforms. And then you also have some of these other types of scam methodologies where people reply to tweets and link this way to earn yield by using this arbitrage bot. Now, talking about some of the more interesting scams in the space that we've seen over the last couple of years are drainer kits. A lot of drainer kits actually started around May of 2022, with Monkey Drainer being one of the first drainer kits that kind of originated. Now, what's really interesting about Monkey Drainer and the origins of drainer kits is that it kind of replicates a business model that you see throughout the traditional cybersecurity space for like malware as a service, but now introducing it in a different aspect as drainers as a service. So how this actually works, oftentimes is by approval farming. So when the early days of Monkey Drainer came about, they kind of were very targeted towards the NFT space. So what they did was they leveraged your open approvals that you already had on assets you've listed in the past on OpenSea or other platforms, and they essentially leveraged those approvals to essentially create a zero ETH listing to themselves, effectively draining you of your assets. Now, throughout his notoriety, he stole around 16 million USD before shutting down his operations. And from then, you had the rise of Inferno Drainer and Angel Drainer, which are some of the other more prevalent kits in the space. Inferno Drainer has stolen roughly around 80 million in assets, employing a lot of the similar tactics that Monkey Drainer had used in the past, but also leveraging newer techniques by using things like potentially over-engineering of certain protocols. Like Uniswap, for example, has a functionality where you can actually swap to another wallet address. And the intention behind this feature was so that you could swap directly into a cold wallet. But now, from an attacker's perspective, you can swap directly into their wallet. So by leveraging things like this, you can see what the pop-up might look like on WalletGuard. This was an actual transaction that was blocked. And the idea was just swapping directly into the attacker's wallet. Now, Angel Drainer is another really prevalent kit. Now, what they really employ that's a little bit different about them is their multi-chain draining strategy. As of recently, through efforts of MetaMask and the Security Alliance, Inferno Drainer has kind of shut down and started to work with Angel Drainer. So there have been a lot of changes and evolutions in the draining industry as a whole, but it's a constantly evolving field, and that's constantly affecting end users, given the idea that a lot of people sign transactions without really thinking about them. And what we're really trying to do nowadays through transaction simulation that a lot of wallets use is trying to portray to end users what exactly happens when you are actually committing a transaction on chain. Now, pig butchering and dating scams are also a massive, massive, massive plague on the industry. You see, hits from like $5,000 to like hundreds of thousands of dollars. So these are very targeted attacks. They typically start on dating sites like Tinder or whatever else. And the idea is it can be as simple as a hey message and then lead to somebody asking to invest on some investment platform. Oftentimes it acts kind of like a Ponzi scheme in the beginning where you put money on there, you start earning, and then you trust it and you start investing even more money. Oftentimes that's why they call it pig butchering, because they fatten it up before they actually take the big hit and take every asset you have there. Now, this is also the, out of all the scam methodologies, this has the highest amount of return for the attacker per hit. Now, security is an ever-evolving cat and mouse game, but be assured that there are companies like MetaMask, Security Alliance, Blockade, and many other security vendors that exist out there that are constantly working on mitigating these threats. And that's all I have for you today, but I'm happy to take any questions.
Thank you, Owen. Questions? Please raise your hand. We're getting more crowded. Oh, there. Do you want to give it a try? I don't think I can make it that far. Thanks.
This might be embarrassing.
Ooh.
So question about the future of all those sophisticated techniques and drainers. Basically, we discussed the current state of them. From your experience and just looking at all the different smart contracts that are malicious, what is the future of that operation that malicious actors are performing? Where is it all going right now?
Yeah, it's an interesting one because it's an ever-evolving field. MetaMask has released some features as of recently to do a lot more on the client-side detection feature sets, and it's actually mitigated attackers very much so to the point where Inferno Drainer has consolidated into Angel Drainer, and other drainers have completely shut down, and we've made the barrier to entry for draining significantly harder than it's ever been. So it's a constant cat and mouse game where when we take out or disrupt one piece of infrastructure, they're going to migrate to another piece of infrastructure. Typically right now we see a lot of infrastructure being leveraged like Cloudflare. So some of the bottlenecks that exist in the industry, for example, is people like Cloudflare who aren't taking as active measures to mitigate these threats. So it constantly evolves though. So if Cloudflare were to do something, they're going to migrate to something else, and that's why I called it a cat and mouse game.
There's a question at the front row, lady. Oh, there's one at the back first? Okay, please.
So I have a question. What are the techniques for detection for these malicious transactions? For example, what differentiates a malicious approval from a non-malicious one?
Yeah, so that's a good question. So in the case of Inferno Drainer or Monkey Drainer or some of these pass draining kits, it's actually leveraging legitimate approvals. So if you leave an open approval on your, let's say you were on Uniswap and you left an approval open for your for an asset you're going to swap, and you never revoke that approval afterwards, that approval could be leveraged to steal your assets in the future. So this is why having good hygiene on your wallets by revoking things that you don't need is a really important tactic. So back at WalletGuard, we released a product called our security dashboard, and it would run a whole scan of your wallet to check all the different assets you might have and the open approvals you have. So the idea was that lingering approvals are not a good thing, and if you're not using that approval, you should have it closed out.
I think the
Test?
microphone is not working. Oh, yeah.
Oh, okay, there it goes. My question is essentially, it might be a little bit more philosophical, but I feel like there's a lot of creativity applied on the other side with black hats. How do you feel we can be more creative from our side in terms of protecting our assets and being proactive about preventing hacks?
I think a lot of those responsibilities, security is actually falling on the wallets themselves. More and more, one of the reasons that we were so keen to do the acquisition with MetaMask was because I truly fundamentally believe that security should be built at the wallet level. And it allows, by having security built at a wallet level, you get to impact transactions at a different level. Back in the days when we were operating as WalletGuard, we were essentially a browser extension that would be kind of a companion to your wallet. And as good as it wasn't the level of the stack we want it to be at. And I think that's why security really should be built at the wallet level, where the transaction's actually being controlled. So taking control of that transaction lifecycle is the most important thing we can do as on the blue team side.
Thank you.
Thank you so much, Gime. Let's give it up to Gime. Sorry, to Otham. Right, we're coming up to the last half an hour, and we only have 3 speakers left. Next coming up is the CTO of Ledger, Gime. Sorry, I just pre-announced his name just now. Can't get more excited. So he's going to change your mind about blind signing, and he's going to tell you why DeFi can't move forward without clear signing. Let's welcome him.
GM, everyone. I'm Charles Guillemet. I'm CTO at Ledger. And today I'm going to talk about clear signing and why it's important. If you care about security, you must have a Ledger device. Raise your hand if you own a Ledger device. Okay, most of the people in the room own a Ledger device. But would you sign the transaction? Raise your hand. You wouldn't, but most of you have already signed the transaction. And it's a big problem because signing a hash is completely insecure because you can't distinguish a legitimate transaction from a malicious payload, and you might sign away your assets. So this is something we need to fight against. This is what we call blind signing, and blind signing is simply equivalent to signing a blank check. So maybe you are signing the transaction you wanted to sign, but maybe you are signing away your assets. And unfortunately, getting scammed isn't fun, and this is very real. A couple of months ago, WazirX was hacked, 230 millions, and they simply blind signed transaction, giving away their assets. Only 2 weeks ago, Radiant Hack Capital got hacked. Same story, they got malware on their computer. They thought they were signing a transaction on safe, while the malware was replacing the transaction by a malicious transaction. They blind signed the transaction and they got hacked. So these attacks aren't theoretical at all. They are very real. They are part of our reality, and we really need to fight against this attack. And the idea for us is to provide the user with all the information to take a decision to sign a transaction or not. So the idea is to have something very transparent, completely human-friendly, and to empower user. Again, Ledger won't decide for you. We just give you the information, and then you decide if you want to sign the transaction or not. And in this case, you will swap your Matic to USDT. Everything is clear, and you don't have to guess if the hash is dangerous or not. The key component for the clear signing initiative are quite simple. We have created a standard that is based on a JSON file. So we are asking dApps to create a very simple JSON file that explains how to interact with their ABI and to give like the human-friendly name for the different method and parameters. We also provide an editing tool to make this as easy as possible. Then there's a metadata file will be stored on some public registry. And for wallets, then it's a matter of trusting this metadata file or not. Ledger is one of the trusting authority for this metadata file. We sign this metadata file, and as soon as you will sign a transaction, the whole transaction payload will come along with this JSON metadata file that allows the hardware wallet to understand how to parse the transaction. This is how it works. And if you are a wallet, from an integration standpoint, it's pretty easy. You just have to integrate our last version of the device SDK. So to summarize, from a dApp standpoint, you just have to fill this metadata file with the tools that we are providing. And for wallets, you simply have to integrate the last version of the device management kit, and then the clear signing comes for free. The device management kit is pretty easy to use. It allows to discover devices, to connect to the device, to exchange data to the device. There is also some state management that allows the wallet to know where the hardware wallet is, and several OS commands. The visualization tool is also pretty convenient for dApp developer. If you are a dApp developer and you have written your smart contract, you won't need more than 10 minutes to fill the metadata file. And with this tool, you can see what will be displayed on Ledger devices. You should care. This is not like a Ledger problem. It's an industry-wide problem that needs to be solved. We need to fight against these attacks. We need to rebuild trust in the ecosystem. We see more and more sophisticated attacks, and that won't stop here. With more stakes, attackers get more sophisticated, and we will see more and more people who are drained and so on. So we really need to solve this problem, and we won't be able to solve this problem alone. So we need your help as developer, as dApp developer or wallet developer, to make this a reality. Here, a couple of useful links. So you have the developer portal, you have the clear signing on page, you have the GitHub repository, and a blog post explaining how to interact with the clear signing initiative. Thank you for your attention, and happy to answer to your question.
Thank you. Question.
Okay, I have a small question. It's a little bit off topic. Can I ask you about after the section?
Sorry?
Can I ask one question when you will leave? It's a little bit interesting for me, but a little bit off topic for now.
Okay, okay.
Thanks.
Okay, we have a question behind.
Has like Open Zeppelin implemented that for like all the regular stuff, like for vaults, for example, so we don't have to do it?
Yeah, very good question. Not yet, to my knowledge. We have created the open standard recently. We asked for, we implemented some RFC in order to get feedback from the community and so on. And now we are in the phase where we are asking different dApps to fill the JSON file. And the generic parser at the device level will be available in like a couple of weeks, like in 1 month, something like this. So it will come, but to my knowledge, they didn't do that already.
So for now, it's on each dApp.
Yeah, each dApp needs to fill this, this JSON file. Again, it takes 10 minutes, but it needs to be done by dApps because they know how to interact with their smart contract.
Yeah, thanks.
Thank you.
Yeah, here. I wanted to ask if this is, here.
Okay.
Yeah, if this is for any kind of signature, not only signatures or transactions, and if you do some validation on the JSONs that the developer propose, or is totally like decentralized or something like that?
Okay, very good question. So for now, we focused on EVM mostly. So all of this is valid for EVM. We will continue the work on other chain next year, but for now, it's only on EVM. We are supporting already the approvals, permit 2, EIP 712. And for the metadata file that needs to be done by dApps, we have created a public repository, so anyone can contribute. But when it comes to trusting the metadata file, each wallet is responsible to signing or not this metadata file, and Ledger is a certification authority for this metadata file. The transaction that you will sign on your device, if they are clear signed, that means that we have reviewed the metadata file and then we think it's legitimate. Thank you. Any other question? If we have still time for one question.
I think there's one there.
How do you ensure the integrity of those JSON data files?
So they are simply signed by a ledger key, so they can't be modified.
I think
Hello?
we have a question there, yeah.
Hello. I'm probably missing something, but what's the difference between this and NatSpec? Because I thought NatSpec was supposed to solve this problem.
Which spec?
NatSpec.
NatSpec. To be honest, I'm not aware of NatSpec. We have created this specification at the beginning of the year, and we have discussed with the different people in the ecosystem, asked for feedback and so on. And to be honest, I don't know this specific spec.
So NatSpec is where you embed the intent within the source code using special comment format, and then that stuff can get tracked in a decentralized manner.
Does it enable to explain how the transaction is actually implemented?
Yeah.
In order to parse it?
Yeah, it's about 3 or 4 years old, I think.
Okay, but what we have created is a standard that also gives some formalism on how the JSON file must be done so that the device understands it. So maybe the difference between what we did and NatSpec is around this, the specification of the JSON file.
Thanks.
Thank you.
Thank you very much.
Let's give it up to Guimei, CTO for Ledger. Okay, our next talk will be from Kim. Kim is the CTO and co-founder of Blowfish. He will be sharing his experience for simulating user transactions in the last 2 years, the good, the bad, and the ugly.
All right. Hello, everyone. So my name is Kim. I'm the CTO and co-founder of Blowfish. For the past 2.5 years, we've been doing security services for wallets, essentially simulating and doing security metrics on transactions before the user signs them. And in this talk, I'll give you a very abbreviated version of some of my learnings, or as I like to call it, the good, the bad, and the ugly of transaction simulations. So starting out with the bad, a naive approach to simulation. Simulating a transaction seems super easy. You do a debug trace call. You can look at the transfer event submitted. You can look at the storage. And you're good. You can see this transaction transferred 10 USDC. You're all good. Unfortunately, this is not the case because we are in an adversarial environment. And as we heard in the previous talks, there's a lot of money to be made by circumventing security tools. So you have to deal with a bunch of things like malicious, malformed tokens, contracts emitting fake transfer events, and one interesting thing, red pill attacks, which is essentially an attack vector where a malicious contract tries to inspect its environment to determine, am I running inside of a simulation or am I running on-chain? If I'm running in a simulation, I'll show an outcome that's great for the user. You're getting a bunch of tokens for free. It looks great. While on-chain, when it's executing, it's actually stealing a bunch of tokens from the user. And the important thing here is that bad simulation can actually be worse than no simulation at all. So that brings us over to the ugly, which is the current state of simulation that we have in production. So what we're doing at Blowfish is we have a fully custom EVM execution environment. We try to mirror the on-chain environment as closely as possible to eliminate these red pill attacks. We look at the actual state changes. We don't look at the events because that gives greater accuracy. The problem with this approach is that multi-chain becomes quite difficult. We have a plethora of different chains, and they're all EVM similar, but not exactly the same. That opens up to a bunch of problems and red pill scenarios that are difficult to deal with. But does this actually solve the problem? Unfortunately, it does not, because as we upgrade the tech, the scammers also upgrade their tech. So one thing that we've been seeing in the past year or so is a rise in bit flip attacks. And what a bit flip attack is that the malicious actor, the user signs a transaction, then the malicious actor submits another transaction to front-run the user's transaction to change some state in the smart contract, which alters the outcome. So when the transaction was simulated, looked great for the user, they sign, they submit, it gets front-run, something changes, the user loses all their funds. And this is one of the most common attacks that we see in the Solana ecosystem today, and it's probably going to get more prevalent in EVM as well, as simulation sort of gets more and more commonplace in wallets. Another, can we prevent this with using a private mempool? Not really. It makes it a little bit more difficult for the attacker. They can not look at the public mempool, but if they own the UI, they can probably figure out roughly when they need to send their transaction to sort of front-run the user in the next block. And we've also seen that they're having quite a lot of success with this in production. So what we've been working on is trying to enforce the simulation results on-chain. And this is quite interesting because then if the execution on-chain significantly deviates from what we simulated, the transaction will revert, so the user will not lose any funds. This is something we put into production and experimented with on Solana, and it's showing great potential, and it's actually stopping quite a bit of scammers from stealing user funds. But when you look at it a little bit closer, so when you're enforcing the simulation results, we start to think about what does the user want to achieve. That is the simulation results, what they want to achieve. And that is basically an intent, basically a different way of doing intents. So that brings us to the good, simulating user outcomes instead of transactions and inputs. So intents may be the way forward to safe on-chain transactions, but the question is how do we get there? And just like the previous speaker was talking about, it's very important that we have standardized framework for translating these intent messages into something a normal human being can understand. So this is a great opportunity to show what you see is what you get experience directly in the wallet, where all the user cares about is, I'm swapping 1 ETH for $5,000, and it's going to happen within 1 hour, or it's not going to happen at all. And I think that this could significantly decrease the number of scams that we're seeing, because the problem today is that users are signing transactions without a full understanding of what will happen. And that was a very abbreviated version of some learnings from the past 2 years. Thank you all.
Thank you, Kim. Any questions? Oh, we have one at the back. Okay, I think we have one there.
Okay. Hey, I'm Titus from Civic. Who's responsible ultimately for the transaction simulation? Is it the protocol, the wallet, the third party that like is blocking the transaction? Who ultimately is dealing with all this, like in your opinion?
Yeah, so currently how it works in our flow is that the wallet receives the transaction from the dApp. They send it off to us. We run the simulation, and we return back the simulation results with all security warnings, if any. And then the wallet can show that to the user before they press the sign button. So essentially, it is within the wallet's responsibility, but a wallet needs to do a lot of things. So maybe this is something that they do want to outsource to professionals.
Oh, so we have a, no? Okay. Any more questions? Oh, there's one back there.
Hi. I tried writing a red pill bot. I didn't know there was a name for it. But one of the things that I kind of assumed that people would be aware of up front is that if I tried to execute some code which depended on not code, which was environment dependent, like the chain ID, for example, then I guess, would that not be filtered out by like sensitive transactions? Does that make sense?
I think so, yeah. So yes, you could look at sort of what is being called as part of the transaction, and you could have heuristics for this to try to filter this out. That is a valid approach. However, then you need to sort of catch all of them, right? And there are some maybe valid use cases to be looking at the gas price or the base fee or something, so you might have some false positives. So we try to go the other route and try to make our environment as production-like as possible instead.
All right, thank you.
Okay, thank you, Kim. Thank you so much. Now we are going to have our last talk of the day from Chi Su. He's a security engineer from Fuzzland. He's going to show us the attack and defense game in the MEV world. Let's welcome him.
Hello, everyone. My name is Shi, and I'm a security engineer at Fuzzland. And for the past year, we have been digging into the MEV world, so we have some insights to share to bring some new methodologies into this world. And the topic is how to fund-run a transaction in the future. So in 2023, we have seen a lot of fund-runners has rescued millions of dollars in the hack incidents. For example, like Compiler, they rescued 5.4 million, and also BlockSec. And also in the KyberSwap incident, they rescued 5.7 million and returned those funds to the protocols. These are like white hat hackers. But we are seeing a declining trend for this in 2024. And there are some reasons for that. So before that, let me go over about the background of MEV and fund running. So this is how a transaction's lifecycle. So on the top, you can see when the user wants to send the transaction, he wants to send it to the builder first, then the validator. Then the validator will propose a block and commit it to the chain. But if there is a front runner, when the user sends a transaction to the builder, the front runner will see this transaction and when he detects this transaction is profitable, he'll replace the beneficiary to himself and then add a little bit more gas onto that. So the builder will place his transaction in front of the normal transaction. So the user's transaction will be reverted. So the front runner will gain profit from this. So then the role of private mempool came. They say we will keep transaction private. And this is beneficiary for most parties. First, arbitrage are fair, like MEV bots, they want to balance the pools. They find a better swap path win. And also user, they don't need to suffer from sandwiches. And also the side effect of this is that hackers' transactions, they are protected by the private mempool as well. For example, in the previous examples, those front runners are not able to front run with a private transaction. And is front running dead? And we found the answer to this question is no, not on a block level. Let me explain that. So we have seen a lot of patterns like this. It's called a two-phase style attack. So first, if a hacker wants to hack something, he will first deploy a assistant contract and do some preparation. And finally, he'll send another transaction to trigger the vulnerable function of the victim. So to exploit it, all a MEV bot or a front runner needs to do is to extract all the functions of a contract by using the function signatures and call every function. And if it happens to be the trigger function, a front runner will be able to front run this transaction that has never been sent to the builder before. And so it becomes a cat and mouse game between the MEV bots and hackers. And there are hackers, they thought of some better strategies to protect their contracts. For example, here we have address verification. But it's easy to bypass. All a bot needs to do is to add some hints. And also if it has an authentication, like here you have a hash of some address. If it's compared to a fixed hash. But all a bot needs to do is to change that equal sign to a not equal sign. And also then hackers thought of some more sophisticated methods. For example, they hide the parameter to the vulnerable function directly in the parameter in the function. And we found that the goal is really to find the input to trigger a profitable path in the contract because it's already in this contract. And fuzzing is a good tool to do that. So what is fuzzing? It's basically generate a random input. This random is not really random. And then it execute the program, observe and analyze the execution, collect interesting information. And if it's a profitable path, we will exit. Otherwise, we repeat using the collected information. And there are different purposes for fuzzing. In Web 2, it might be corrupting some memory. In Web 3, all this space, it might be breaking some invariants. And here, we are really to find a profitable path. So the effects really depends on the input generation. Here are some heuristic functions or generation methods we want to offer you. And the important thing is about the heuristic functions. These are that makes the fuzzing different. And there are some pros and cons to fuzzing. For example, it's fast, accurate, and easy to build a prototype. And also for the cons, it can be time consuming, especially in some chains that have a very low block time interval. And what we want to promote is that I think we should bring more Web 2 methodologies into Web 3. For example, we haven't seen static analysis, something like that. We're bringing fuzzing, also added some taint analysis and symbolic execution into our engine. And yeah, we're hoping to see more of this. And that's the end of my talk. I'm ready to take any questions.
Thank you so much, Chi. Any questions? The last chance to ask questions before the end of today. Anyone wants to give it a go? No questions? Okay, thank you, Chi. And that wraps up the day of Lightning Talks. What an incredible series we had today. And thanks for all attending and all our speakers. And tomorrow we'll continue. So hopefully see you tomorrow.